Hello, and welcome to our third annual UnoConf. We're excited to have you join us today. My name is François Tanguay. I am the CEO of the Uno platform, and I'll be your host today. I'll be joined shortly by Jérôme, our CTO, in just a bit. As much as I'll be your host, I'll primarily be your spokesperson for the team of core engineers and the hundreds of community contributors behind Uno. Open source is the present and the future of software development, and we're proud to have been developing Uno in the open for the past 3.5 years. We're especially proud of what we did so far and the traction we're getting with both the community and the organizations, large and small. Our vision since day one has been to reduce waste in the software development industry. To accomplish that, we chose to bring WinUI everywhere for a ride and enable developers to create pixel-perfect, single code base, web, mobile, and desktop applications using both C# and XAML. Today, we'll share an update as to how far along we've come with Uno and announce significant new improvements and hopefully show you why we call it a platform. You'll hear from key contributors as well as from those with Uno apps already in production today, betting their company or future on it. You can ask questions right now online using the UnoConf hashtag. Our team is here to answer your questions on both Twitter and YouTube. The theme of this year's conference is maturity. Let me explain. Uno has matured, but first let's talk about the ecosystem we're sitting on top of. There's WinUI 3, which just shipped as part of the WinApp SDK 1.0, bringing decades of investments forward. Then there's WASM, which is rapidly evolving with threading, exception handling, and WASI. Then there's .NET 6 that just released with massive performance improvements and new language capabilities. And finally, there's VS 2022 bringing 64-bit support to all platforms, which brings more productivity at your fingertips. Last year alone, on the Uno side, we closed over 700 issues and added new controls and capabilities over 11 different releases. We've seen performance double in many scenarios. But most excitingly, Uno has been downloaded over 1.3 million times and inspired a community of over 200 contributors. Speaking of contributors, we're flattered by the love we're getting from the Microsoft MVP community. We've had over 25 of them contribute to Uno so far. One of the MVPs with passion for dev productivity is Vincent, who's been working on porting the C# for markup extensions to Uno platform. If you don't know exactly what C# for markup is, you can see here that you're able to define your entire UI using only C# and getting rid of all the XAML. What that gives you is the possibility to use productivity tools like .NET Hot Reload and see those changes in real time in your application, getting immediate feedback. If you want to learn more about C# for markup extensions, please go visit Vincent's repo. There's also Microsoft, who's been actively contributing to the Uno platform, both individual developers from various teams, as well as one team specifically, the Surface team. Craig Dunn is here with us today to tell us more as to why they contribute to the Uno platform.
Hello everyone, my name is Craig Dunn and I work on the Surface Duo developer experience team at Microsoft. We are big fans of the Uno platform. .NET developers like me and you have been targeting Windows devices of all shapes and sizes with XAML since WPF, and it's amazing to see Uno bring that familiar syntax to apps that run on the web, iOS and Android. Uno platform had support for Surface Duo when it launched in 2020, using a Microsoft SDK to light up the two-pane view control on Surface Duo devices and respond to hinge angle changes. Since then, we've launched the Surface Duo 2, our latest Android dual-screen device. On the software side, Google has been working on a platform-level API to support foldable devices called Jetpack Window Manager. As part of Microsoft's commitment to the foldable ecosystem, we wanted to make sure that the dual-screen support in Uno extended to devices beyond the Surface Duo. So we're really happy to partner with the Uno team to contribute an updated package, uno.ui.foldable, that provides Jetpack Window Manager support, and through it extends two-pane views features from Surface Duo to folding devices from multiple manufacturers. Here are some foldable-aware Uno platform examples running on Surface Duo 2. First up, the Samples app for Uno contributors, which is a great way to take controls like two-pane view for a spin. Then there's this demo from the Uno team last year that has a bit of fun with the hinge. Next up is a simple calculator by community member Nick Randolph that I've adapted for 2 screens. And finally, this is an update to the Channel 9 video app to make it fold-aware. Because we're now using Google APIs, these can run on other foldable devices, such as the 7.6-inch fold-in emulator available in the Android Device Manager. You can download and try these samples on GitHub. And that's all I've got to show for now. Congratulations on another UnoConf and all the innovation you're sharing this year. We're thrilled to be a small part of it and can't wait to see the apps the community builds. Back to you.
Thank you, Craig and the Surface team. So now, because you must have been waiting for this, I'm proud to announce the release of Uno 4.0. Let's unpack it. So first, because we do need a runtime, I'm happy to confirm that Uno 4.0 is running today on top of the new release of .NET 6. And second, because we do bring WinUI to all of the other platforms, I'm also pleased to announce that Uno 4.0 is now supporting the latest release of WinApp SDK 1.0 and therefore WinUI 3. Obviously, we're already playing with the .NET 7 bits in order to continue offering day zero support for all of the upcoming releases. For us, Uno is more than just a UI framework. Since day one, we wanted it to be an all-inclusive platform that offers everything you need to build an app efficiently. We started with themes, where you get Material, Cupertino, and Fluent styles out of the box. What that allows you to do is to create pixel-perfect applications while keeping native behaviors where it matters. This is the beauty of lookless controls through control templating and the rich styling of WinUI. As a next step in Uno's journey, today we're introducing a new set of productivity helpers for Uno as part of a package we call Uno Extensions. The first of these extensions is what we call app templates. It gives you everything you need in terms of patterns and recipes to get you going. It builds on top of services extensions to add dependency injection, logging, serialization, and a bunch of other helpers that will be helpful for you when you're building an app. The second extensions we're shipping today is something we call Uno Reactive. There's been this whole duality between 2 well-known patterns in UI design, MVU and MVVM, and we've been using something entirely different internally for a long time, and today we're happy to announce that we're open sourcing it. Uno Reactive is about managing your state in your application in a declarative, immutable, and reactive manner. There's 2 well-known patterns, again, as I said, for MVU and MVVM, and on the red corner, you have MVU, right? It is where you model your whole application state, your view state, your responsive state as something global for which you are able to render your view. On the blue corner, you have your old friend MVVM that, yes, leverages the power of data binding, styling, and lookless controls, but it has its own demons, mainly iNotify property changed and value converters. We believe that we can have the best of both worlds, and that's what we coin internally MVUX, MVU for XAML. It allows you to write business code as a reactive, immutable, declarative set of code, and we generate all of the glue required to make your XAML happy. This is worth its own dedicated session, and that's why we'll be publishing hands-on guides about it in the near future. We're also shipping more extensions. Navigation is one of them, and you'll hear about it in Nick's session later on today. To show you more about all of these extensions in action, let's go to Jerome.
Thank you, François. My name is Jérôme Laban. I'm the CTO of the open source project Uno Platform, and I'm going to be talking to you about the Uno Platform extensions that we're releasing as part of Uno 4. To get started with this, you're going to be having to install either the Visual Studio extension or the Uno.NET New templates. On screen, I'm showing you the way to create those templates with .NET New, Uno app extensions with the optional material design. And in the interest of time, I've created this application already with a sample that's called the Commerce app. And this application is a basic application that you could find that uses all all sorts of features that are provided as part of the Uno extensions. So in Uno extensions, when you create the application, you're going to see the standard template you're going to find with an Uno application using Android, iOS, macOS, a shared project which contains all the source for your application and a few other targets that are available. I'm going to be demoing with the WebAssembly application, and you can see here that there are dependencies with configuration, core, hosting, HTTP, localization, all features that are providing additional value to your application, so you don't have to develop for your application all those specific concerns. Now let's talk a little bit about the Uno host, which is a class that's using the generic host from Microsoft, from the Uno extensions. And this provides a way for setup, initializing and create and set up all your services and IOC containers using the generic host that's provided by Microsoft. So you can get your application settings, your logging, and configure the level. You can use Serilog, or you can use all the settings and features. So if you want to store the login credentials for your users, but also set up the services and a few other things like navigation that Nick is going to be talking to you about in a few moments. So that's the base structure of an application. Now, to demonstrate one of the specifics of Uno extensions, Uno extensions reactive, let's talk about state management in applications. You can see here on the right a page that does search through an asynchronous source, and the state management of all this can be somewhat complicated. Now let's take a look at the view model that's associated to this. You can see that it's a class that has no iNotify property change, and it has no state. There are only variables that use feeds. And what we're doing here is when the user types some characters in the search, then if there are more than 2 characters, we're going to get the data from the server, come back, and show loading state if that's needed, but also show an error or the values so in the list when available. So to manage this, we're using feeds, and feeds are completely immutable and reactive and allow for you to combine a set of sources. So for instance, we have the products, which is a feed that gets the data. We can merge that with the filters and then show the data. And to show you that we can have the loading state, in here, if I change the data, for instance, if I use a smaller search, you can barely see the state of this changing. Let me change this and show you what that means. So the list of data that's shown here is done by what we call the feed view. It's a control that automatically manages the state of the data that's coming from the server. And if there's something to be waiting, or there's an error, or the data that needs to be shown, it changes the data to show the proper state. So let's change let's make the data source pretty slow. So let's change it to 5 seconds, for instance, 3 seconds, for instance. Let's rebuild the application, and we're going to see that now when we're searching and changing the content of the text box, then the loading state will change and will show you the application will change its loading state and take more time to get there. So let's manipulate the list here when the application is there. So let's see if I change for shoe. You can see here that there's going to be some loading here that happens here for about 3 seconds, and then the data is going to show up. So that's how we can manage state automatically by using feeds and feed view from the UI. So I hope you're going to be able to use the Uno reactive extensions to enhance your applications and develop them faster and go to market. Let us know how that goes for you, and thank you. Back to you, François.
Thank you, Jerome. It's great to see how quickly you can get a fully architected app running with a simple .NET new command. Today, we're also introducing yet another addition to Uno, the Uno Toolkit. It contains a bunch of controls that aren't part of WinUI as a desktop-focused technology, but do make a lot of sense in a multi-platform world. First, you have the tab bar, both in bottom and top formats. Then the navigation bar that allows you to navigate easily between your pages. Then there's the surprise auto layout control. You'll learn more about this later. We also have drawer that allows you to swipe from any size, plus a variety of more controls also shipping in the Uno Toolkit. To see more about these controls, let's go back to you, Jerome.
Thank you, Francois, for all the details about the Uno Toolkit. So it's all about getting your applications to be readily available on your devices, so you don't have to spend time developing controls that are present in many applications. So we're providing a set of controls that are available as part of the Uno.UI toolkit with Cupertino and material designs. And you can use those by integrating the Uno.UI toolkit NuGet package in your application. So in here, I can show you an application that runs the tab bar and a few examples about that control that is available as part of the toolkit. So I can show you that it runs at the top, for instance, and you can select the items at the top and you can move around and change the active control by sliding on the side. That control is using the native primitives to render itself. So that means that it uses the native controls and depending on the target that you're running on, but it's also styled. It can also be styled to be a bottom bar. So for instance here, I can click on the home button or have a flyout that allows me to have a pop-up that allows me to select what option I want. Then you can say the same control but running for Cupertino this time. It's the same kind of control but styled differently. So if I run the same thing, you can see here having the same behavior that you saw with material. Now with the same kind of controls, we're going to see down the segmenting control. Segmented control is giving you the same kind of ability that you can see in the UI designs for iOS, and but readily available for Uno platform. You can also have the card content control. The card content control is a control that is provided as part of the material design, and that control can be also used when referencing the Uno.UI toolkit control. I've shown you the application running on iOS with the toolkit controls. Now let's take a look at the controls running on Android. This is the same application running on Android, and it uses the same set of features with the tab bar at the bottom that allows you to navigate through the pages of your application. And in here, you can also see that we do have navigation from one page to the other. So for instance, here, I have the top navigation with the ability to go back and have some top navigation items as well as the bottom navigation items. So I can also go to the profile page and show you that the tab bar also supports theming with light and dark theme. And that allows you to navigate through the application with proper theming available for all your applications. So that's about it for the Uno UI toolkit. And I hope you're going to be able to use it in your applications. Thank you, and back to you, Francois.
Thanks, Jerome. It's good to see that we found a replacement for that famous pivot control. Now, this is really where things are getting interesting to me. This is the vanilla experience you have as a .NET developer using Microsoft tooling when you want to build multi-platform applications. It's a complex web and matrix of features, IDEs, operating systems, and capability gaps. It took us a while to figure out, but we thought we could do something about it. Today, we're happy to announce C# code completion for VS Code. It gives you the same experience you'd have with IntelliSense and Visual Studio, but within your favorite VS Code environment. We're also announcing C# hot reload for VS Code, so you can make modifications in real time and see the impacts of these modifications within your app running without having to restart and rebuild your app. But that's not all. We're also adding XAML hot reload in VS Code, so you can make those same modifications directly in your markup and see the impacts in real time. Finally, all of these tools are also available in Codespaces and other IDEs. By releasing these tools, we believe we can close most of the gaps in the tooling right now. To see it in action, let's go to Jerome.
Thanks a lot, Francois, for those details about the Visual Studio Code extensions and tooling that we're providing as part of UnoConf. What you're seeing here is all about getting your applications running on all platforms and on all your development environments. The important part is to make sure that we're enabling developers to develop where they want to. In here, what you can see is Visual Studio Code running on Windows with the Uno platform Visual Studio extension installed, which provide a set of features around XAML and hot reload. And I'm going to be starting an application, so the commerce applications that you've seen, running on WebAssembly, started from the command line of the Visual Studio that I've just run. So I'm starting this and putting it on the side. And the application is running, and I'm going to be taking a look at what this application does. So what you can see here is that when I resize this application to be in portrait mode for mobile, there's a small logo at the bottom, which is about to showing the cards for your users of the applications to be engaged more and have something that forces and incites users to use that feature to buy your products. And it looks like the button here is not the right one. So I'm going to be changing this to be using a fab button. The fab button being more visible for users so that they can more easily click on that button. And now I've just updated the UI so that it shows the button as a fab button. Now another thing that I can go take a look at is the profile page. In the profile page, I can see that there are a few features, and especially a feature that allows me to switch between dark theme and light theme. And it shows that the position of the button or the toggle switch is not available to change the theme. So we're going to make that change and make the feature work. So what you can see here is that the visibility of the toggle switch is not available. So I'm going to be changing this and use IntelliSense for Visual Studio Code. And what you can see here is the result of the Roslyn, the use of the Roslyn APIs and features that allow to have the values of properties and everything that you need to have for designing your XAML without having to type all of this and know all the APIs. It works for a few other things like getting access keys or getting actual width and other properties like this. So when I change and I save, I can see now that my toggle button is now available. Now, if I click on it, nothing happens, and that means that there's probably something else that's missing. So the first is to react to the toggled event, and for this, I'm going to be using the IntelliSense for Xbind, which provides me all the functions that match the signature of that toggled event. Now, I've updated this event, and the UI refreshes, and nothing's still happening, and that's probably because something's happening in the code behind. So now let's go to the code behind, and I can see that in my code behind, I'm missing a piece here, which is the fact that the set application theme is not working properly. So I'm going to be uncommenting this out, and the application is actually reloading in the back, and the C# hot reload feature that's coming from .NET is now integrated into Uno. And now if I click again in my dark theme button, now the application switches to the dark theme. So that's one of the cool things about using all the features that the .NET ecosystem are providing as part of .NET 6. One of the things that we've done also is to start integrating with the debugger. So let's go ahead and take a look at this feature. Now, I've stopped the debugger, the application from the command line, and I'm starting the application using the F5 key. So now the application's starting again, and I have a breakpoint that's on the toggle dark mode method here. And when the application is actually going to be starting, I'm going to be able to go and be able to debug this application and go and hit that breakpoint. And the important part is that I'm going to be able to see a lot of content that's from my application. So let's see, if I click the dark theme button, I can see that the breakpoint hits, and I can inspect all the values that are provided by this property and get all the details about the content there. So I can see that the profile page has an actual width and height of those values here. So now that I'm done with developing my application on Windows, I'm going to be going to I'm going to go to another target that we're supporting now because we're developing for Visual Studio Code, and that one is code spaces, GitHub code spaces. And in GitHub code spaces, we're providing the same features that you've just seen when developing the application in Visual Studio on the desktop. Now, similar to the feature that you've seen, the IntelliSense is available in the same way, and you can get all sorts of IntelliSense, like is enabled, for instance. When you can get here the properties are of that value. And if I start the application in the same way, so I can run the application on the server. This is GitHub's code spaces servers, so I'm not running anything local. This is the application completely running on the server side. And the cool thing about this is that I can also run my application and see it live and running from the server. So the application is running on the server side, and like if it were on the local environment, like the one that you have on your machine, but it's running on GitHub servers. So the application started up, and this is interesting because that means that you have a complete web environment where you can start up and have nothing to do with installing development environments, installing runtimes and tooling and everything. Everything's just available when you have installed the Uno platform extension and OmniShot that comes, the C# support for VS Code that comes with it. Now, if we take a look at the profile page, we can see that there's an error here where the dark theme, the dark mode is not set up properly. So I'm going to be changing this to be set properly. So the horizontal alignment doesn't need to be center, it needs to be right. So if I update this, I can see that the button now goes to the right location. So another thing that's interesting is that with a web development environment, we can use what is called hot reviews. The idea is that when you're done with your PR, you've created your PR, and then there's the ability to open another online service that's called Gitpod, which is pretty similar to what Codespaces does. And the interesting thing about Gitpod is that it allows you to review the code and have an instant compilation of this, because there's a way to do pre-compilation. And then you have your environment for you to be able to preview your application and the pull request from your coworkers and get all, and don't waste time by building your application because your environment is already set up. So what you see here is an X11 VNC server. So it's a VNC server that goes to an X11 installation on the server side and Gitpod servers. And when I start the application, you're going to see that I'm going to be able to debug the Skia GTK application that runs on top of Uno. And the same application is here. I can go to the profile and do the same kind of modifications here that I had on the other one, where the button was not placed at the right location. So I can just move that and use right instead. And now, if I save again, then the button is going to be updated right away, and I'm going to have my application available, and it's going to be working as you would expect. Now, another important thing is that if you're like me and you have something that doesn't your desktop is not enough, and then you have all those Raspberry Pis around, I probably have too many, and I have just one here that I've been using to develop the application onto. And what you can see here is the same application running on the Raspberry Pi with the same kind of modifications that I've done on the other sides, and with the positioning of the button that's at the right location with everything working properly. I can now change the theming on that application. So this is a Skia application, the Skia GTK application running on a Raspberry Pi using the latest support for Visual Studio Code extension for C#, and using the Uno platform extension to get the same kind of IntelliSense that you've seen in the previous demonstration. Now, to mark that we do love Linux and that we're all about getting our Uno platform running properly on Linux and adding more and more features, I'm just going to go and see what our designers have done to get this. I'm just going to take this and integrate that into our application. Now, let me paste this, update this, and let's see what that does. And there you go. We have an updated application with some brand new design that has been provided by our designers. So that makes a turn of all the features that we're providing as part of the Uno platform, extensions for Visual Studio Code, and all the environments that are provided, like Visual Studio Code Spaces, Gitpod, Linux, and even Raspberry Pi for that matter. So I hope you'll enjoy this set of features. Thank you, and back to you, Francois.
Thank you, Jerome. For me, the real gem here is hot reviews. Being able to review your colleagues' work within seconds, trusting that your review is valuable by seeing the code that you're reviewing run live with hot reload, and an end-to-end web experience with zero setup needed, is for me probably the biggest boost in productivity you'll get all day. But you might be wondering, if you paid attention to Jerome's demo, what was with this XAML at the end? How did it magically appear? This is where another tool comes into play. And this one, trust me, got the whole team excited. Being app developers and builders ourselves, we know how it is difficult to get designers and developers to communicate and collaborate together. On one end of the spectrum, you can go with design handoff, where it's an extremely expensive process of sending design documents over with multiple iteration loops. At the other end of the spectrum, there's this whole design to code magical thing where it generates 100% of your app, but yes, it is a somewhat rigid process. We believe there's a more pragmatic model here, with UI code generation that keeps all the flexibility you need while providing short feedback loops. Microsoft was probably too early 14 years ago when they introduced Expression Blend, but the idea was the right one, offering a design tool that can hide all the subtleties of generating UI code and integrating that code while leveraging the power of XAML as a UI definition language. To bring designers and developers together, we're launching today a free preview of Uno for Figma. It contains a component library of WinUI controls and material components packaged together in something free to download, but it also contains a plugin that allows you to preview live all of your designs as to how they're going to run in the Uno app and generate that XAML automatically into your app. If you wondered how powerful it is, the whole commerce demo app that we've been showcasing has been entirely generated using this plugin. Let's see how you can do the same. By using Uno for Figma, you can customize your styles and align them with your brand. You can also use the pre-built page templates to create a skeleton of your app. And then you're able to use all of the already available components and modify them using variants to see your app come to life. Once your app is designed, you can use a live previewer to see how it's going to look in the app. And by adding mock data, you're able to see real content behave in the app. You You can get both the component library and the plugin from platform.uno/Figma. While project development has seen a great uptake, so did usage. And there's no better way to tell that story than by having those who are betting their future on Uno. Kahua set off to rewrite their decade-old WPF application and make it available on the web using the Uno platform. Let's hear from Colin.
Thank you, Francois, and thank you for the opportunity to be a part of UnoConf. As CTO of Kahua, I not only lead some of the very best developers out there, but I'm also always on the lookout for exciting new technologies which help my team be more effective. At Kahua, we specialize in project management and collaboration software with a primary focus on real estate, construction, engineering, government, and healthcare industries. About a year ago, I set out to look for technology on one of the most important projects we have ever undertaken, the modernization of our WPF line of business application. As you may have guessed, we chose the Uno platform, and I'm here to tell you a little bit more about it. While native hosts work well, there's been a trend in the industry to lock down on software installs. This naturally made us look towards web technologies. Our criteria for deploying required not needing any plugins or extensions or gimmicks of any kind and needed to work in all modern browsers. Due to technical and performance constraints, we were unable to use JavaScript and its associated frameworks. This quickly narrowed the field to WebAssembly and the platforms that run on it, with one standing out among all others, the Uno platform. Performance and security go hand in hand. They're paramount to what we do. As I mentioned, our clients are coming from native Windows applications to the web and bring with them the performance requirements of desktop applications, as well as the expectation the look and feel of the web application be similar to the desktop versions they are used to working with. Additionally, the web application must be secure so IT teams around the world can trust it. The Uno platform satisfies all of the requirements and also provides SSO and MFA integration with Active Directory to further solidify the first-class security of the platform. Our web application must provide accessibility options as mandated by governments, universities, and other public organizations around the world. Therefore, the Web Content Accessibility Guidelines, 508 compliance, and adherence to the American Disabilities Act are required throughout our product. Localization can initially be implemented in simple ways, but from our experience, it progresses quickly and can become highly complex. Any solution we implement needs to support localization in a way that can be nimble and support adding more languages as we go along. With the Uno platform, for both accessibility and localization, we were able to simply reuse what has been developed by Microsoft for its Windows accessibility and localization standards. Currently, we support over 25 languages and can easily add more as we expand around the globe. It took us 10 years and over 1.5 million lines of code to implement the business logic behind Kahua's front-end client technology. This is a huge line of business application, which is the backbone of our product. With the Uno platform, we're able to utilize 100% of our existing code base. Not having to start from scratch saved well over 100,000 hours of development time with an identical experience to our existing WPF desktop application. We love C# and we love XAML. We love the Microsoft and Windows dev stack. We wanted to work with the tools we've been using for over 10 years, and whichever tech stacks we were going to decide on would have to allow our dev team to just pick it up and roll with it. The developer loop of Visual Studio, Azure, and the Uno platform proved to be efficient, and the ramp-up time was very minimal. At Kahua, we are big believers in open source and giving back to the development community. We use the enterprise support model from Uno's team to help expedite certain features for our project, which then made their way into the final project for all of you out there to freely use. For a recent example of this, check out the date and time picker updates from the Uno team in the latest release. The Uno platform's open source principles and developer community have been critical to our success. Many improvements and updates have come from the open source community and from Kahua as well, providing a better solution for all of us. For those interested in developing with the Uno platform, I really hope you have time to try it and find a way to give back to this growing community. To sum it up, we really enjoy the capabilities of the Uno platform and the way it future-proofs our stack. We're looking forward to working with it for many years to come. Thank you.
That was an impressive story of code reuse and fast time to market. And many of our clients have that same scenario, going from WPF to the web. Make sure you check Darren May's session later and see what the best practices are when considering moving from WPF to the web. Many of our customers are ISVs building line of business apps, but you can as well target a business client or B2C scenarios as easily, which is why we're happy to introduce you to our next customer. When it comes down to performance, very few applications are as demanding as stock trading. Milliseconds can make a difference between profit and loss for your end users. And this is why I'm happy to introduce to you today TradeZero, a no-commission stock trading company. They're interesting to me because they were the only ones not to halt trading during the whole GameStop phenomenon, which put TradeZero services, and apps under a great test. Let's hear from TradeZero.
Hi, my name is Dan Carlin, and I'm the VP of Product and Marketing at TradeZero. I'm super excited to be here at the Uno conference to tell you a little bit about our experience with the Uno platform so far. But first, let me tell you a little bit about our team and our tech stack at TradeZero. Our team is led by Costa Corvo, who is our CTO. He previously operated a high-frequency hedge fund for over 10 years using custom-built technology and tools. Since joining TradeZero, Costa has grown our tech team with top-level engineers who are dedicated to quality, performance, and most importantly, uptime. Our flagship application, which is called Zero Pro, is a Windows desktop application with in-house charting built in C#. Our server side is a mix of Windows and Linux that leverage cloud technologies. At TradeZero, we continually evaluate our options to deliver the best possible user experience. So why did we pick Uno as our platform? There's several reasons. First, the UI. We're all mobile app users, and we recognize instantly when an interaction with an app doesn't feel quite right. It could be that the performance is sluggish. It could be that the buttons just feel a little off or don't really respond when they're touched. And with Uno, we feel that mastery, we feel that control really over every pixel on the screen, and we can create beautiful animations that make our customers happy, and that's really the bottom line. And that can be professional customers, or it can be more amateur. We've really been able to deliver to all segments. Secondly is the performance. Financial applications are very demanding. Performance has to be the number one requirement for all of our apps. Our customers expect an outstanding performance on mobile that matches their experience on Windows. And with Uno, we were able to reuse all our existing high-performing APIs and not introduce any UI lag that we may have experienced with some older cross-platform technologies. This created a really responsive app. And most importantly, we were able to reuse our charting control as well, which saved a lot of development time. Third reason that we chose Uno is because of code and skill reuse. Now, I've already mentioned a couple of ways that we reused things, but when, the backstory here is really that when we heard of the promise, Uno's promise of this, single source code base, we didn't really believe it. The story was like, not really viable from our developer team, who all have C#, XAML, and .NET backgrounds. And it really just sounded too good to be true, and never really had been a promise that was delivered on. And then we tried it. And I'm happy to say that we're very close to finalizing our first release of the new mobile. We've executed trades, and we've experienced this native feeling UI for ourselves. The final reason we picked Uno was because of this fantastic collaboration and support that we get from the Inventive team. And we're very excited to see what the Uno platform can bring in the future. Thanks everybody for listening. And now back to you, Francois.
Thank you, Dan. I look forward to trading with your app when it becomes available in stores next year. And I hope all of you check it out as well. Now, over the last year, the same way our team has contributed to open source projects like Prism and Skill we decided to port to Uno a WPF tool that we're using daily, the NuGet Package Explorer. Traditionally, NPE was a Windows-only solution, leaving those developing on Mac and Linux without access to this great tool. The new solution is a WinUI, Community Toolkit, and Uno platform-powered solution, which runs on the web. You can check it out at nuget.info or open it directly from nuget.org. Even better, just go contribute to it. Another one of my favorite projects running Uno is Strix. Let's hear from its creator, Arlo Godfrey.
Hey everybody, thank you so much for joining me here today. And a massive shout out to the Uno team for making today even possible. Over the last month, we've been filing a ton of feedback and asking a lot of questions on GitHub and Discord, and they've been super responsive to all of it. We wouldn't be here without their support, and we're really grateful. Now, before we can get to the demo, and trust me, I am hyped to show you, it's really cool. I need to explain what Strix Music is to those who might not be aware. Now, Strix Music is of course a music playing app, but it has a couple of things that make it super unique. No matter where you might listen to your music today, Now, you might have your stuff, your library stored on maybe Google Drive, Dropbox, a cloud storage provider, Box, any of those. Or you might have one of those streaming services. There's a lot of them out there and they're super convenient. Or maybe you use something way less conventional. Maybe you have a squeeze box or a home media server, or you just keep your files local and you like that. What Strix does is it takes any of those sources and it combines them. It merges them all together and it shows your music in one place. We take that a step further. That's already pretty cool, but we can do more. We take the entire UI and we can swap it to something completely different. It can look like a whole new app in a matter of seconds. That is amazing. But that's not why we're here. Now, to reach as many people as possible, we built Strix on the Uno platform. Let's make some magic happen.
This is Strix running natively on Windows 10. And this is Strix running in Microsoft Edge as a PWA, powered by WebAssembly. To avoid confusion, we'll keep the web version on the right and the native version on the left. First things first, let's pick our UI. We'll pick the Zune desktop skin, a faithful recreation of the classic desktop app. Strix is fully adaptive, but the Zune desktop skin isn't. The fallback skin is used when the app is too big or too small for your primary skin. We'll leave this option as is. Great, let's set up our music sources next. Let's start by adding part of our local library first. Strix is now scanning the folder for audio files. It uses taglib sharp to read metadata from each file, and as a .NET Standard library, it works both natively and in the browser. Now we'll add some music we have stored in OneDrive. We could use taglib here, but it'd be slower since it needs to read parts of the file from the cloud. OneDrive supplies audio tags directly as file properties, so we'll use that. Now for login. We've set it up so the native app has the user enter a code on their phone or a browser for flexibility, while the WebAssembly app uses the browser you're currently in for convenience. Both these approaches allow for the use of Windows Hello. Great, now we pick a folder. This album looks good. And we're done. This is the quick play section. We haven't fleshed this area out yet, but the animations work as expected on both platforms. Let's move to our music collection. Finally, the bread and butter. Strix has combined and scanned the music from our local library in OneDrive into one convenient place. It even found duplicates and merged them together. This is pretty cool. What about that fallback skin we said earlier? When we reduce the window size to something that doesn't work for Zune, it automatically switches to something that does.
Since day one, Strix has been engineered from the inside out to be powerful. It's flexible, it's maintainable, it's extendable, and it's personal. It doesn't matter where your music is stored, or what platform you prefer, or even how you like to interact with your app, Strix has you covered. For the last year and a half, we've poured everything into this, and we still have so much more work to do. We'd love it if you could use the app in its full glory right now, but it's just not ready. The demo you saw today is an alpha build, and we make it available to select Patreons who choose to support us. Thank you so much, and enjoy the rest of UnoConf. Bye.
Thank you, Arlo. That was great. Now let's recap everything we've seen today. First, there's Uno as a platform, on top of which we've added themes to create rich and unique pixel-perfect experiences. And then there's extensions that gives you everything you need to create a functional, well-architected app. We've also added Toolkit that provides you with all the controls you need to create seamless multi-platform experiences. On top of which we're providing you with C# code completion, XAML and C# hot reload, so that you can use them from your favorite IDE on your favorite operating system. Finally, we've showed you today the potential of what is and what could be a design to UI solution with Uno to Figma. All of that together allows you to create single code-based rich multi-platform applications from your favorite operating system. To clarify, all of Core Uno is and will remain free and open source. Thank you all for joining. If you have questions, you can easily find us on Twitter and Discord. And if you want to get started today, go to platform.uno/getstarted. Enjoy the rest of the show.
Hi everyone, welcome to UnoConf and this session where we're going to look at a new set of libraries, the Uno extensions, that will help you jumpstart the development process of your Uno application. I'm Nick Randolph and I'll be walking you through some of the extensions that we've been working on. For web developers, there's a standard recipe that includes dependency injection. That means when you create an API controller, you just specify the dependencies in your constructor and they're automatically injected when the controller is required. For mobile and desktop developers, there's no default equivalent, resulting in applications that are often poorly architected with strong coupling between views, view models, and services. Microsoft has extracted a number of the core capabilities out of ASP.NET and made it available via the Microsoft extensions. This covers hosting, logging, and configuration, to name a few. The Uno extensions are based on the Microsoft extensions and exposes a hosting model similar to what you'd find when building an ASP.NET application, through which services can be registered when the application starts and then subsequently resolved throughout the application. Today we're going to walk you through the Uno extensions from creating a host and registering services through to using the navigation extensions to navigate between pages, views, and the application. At the core of the Uno extensions is the instance of the iHost, which exposes the dependency injection container and the methods to start and stop the application. Application services are registered when the application starts through the iHost builder interface. Service instances can subsequently be retrieved throughout the application. The Uno extensions needs to be registered with the iHost builder and are subsequently exposed throughout the application via the iHost. This all sounds very theoretical, so let's jump in and take a look at some of the code. We're going to start with a basic application that creates a frame and navigates to a login page. This is very similar to most UWP, WinUI, and Uno-based applications. Our design team has already provided us with the various XAML pages, so all we need to do is wire up the application logic. We're going to actually start by creating an instance of the iHost. We're going to follow the standard pattern for creating the iHost instance, which consists of creating an iHost builder, and by calling the create default builder method, and then invoking the build method to return the iHost. At this point, we can already start to query information about the host. For example, the iHost exposes application name, the content folder for loading files packed with the application, and the name of the current environment. Let's go ahead and try and retrieve the environment name and display it to the output window. Let's just set a breakpoint, and now we can go ahead and run our application. What's happening here is that we're going to retrieve an instance of the iHost environment interface that will provide us the information we need about our running environment. So if we hover over here, we can see this is set to production. The environment can be changed. For example, when you're debugging the application, you may want to go ahead and set the environment to development. This might drive different application logic, such as more logging output or using a different input for loading data. We'll come back up here, and we're going to protect this using the #if debug and set the environment to development. Let's go ahead and run our application again. Now when we hover over here, what we should see is that this is now set to development. The default iHost implementation doesn't provide much more than basic services required for dependency injection, loading configuration, and setting up logging. We'll come back to configuration and logging in a minute, but let's first see how we can register some of the services that our application will be using. Again, we're going to come back up to here where we're setting up our iHost, and we're going to go ahead and register some services. So here we can see that we're registering the product services class for the interface iProduct services. Now when we want to retrieve our list of products, we can retrieve an instance of the iProduct service and go ahead and query it, for example, passing a search term for, say, shoes. Let's come back down to our application and enter this code to retrieve the iProduct service and then query using the getProducts method for the search term of shoes. And we can see the return value here gives us a length of 3. So 3 shoes with a listed return from the products. The host builder has already set up logging into the application. However, Uno Extensions provides additional support for adjusting the log level, enabling logging for the Uno internals, as well as using Serilog for more configurable logging. For example, being able to log to a file. Let's go ahead and actually enable platform-specific logging and set the minimum log level for our application. Again, we'll return back to our iHost up here and drop in some code. So here we're enabling logging, and then we're setting the minimum log level to error. Let's go back down and actually adjust our code that we had earlier so that instead of writing to the debug output, we're actually going to make use of our logging. So we'll change this code. It's the same code, except this time we're retrieving an instance of the iLogger interface, and we're going to use that to log out messages. Let's go ahead and set a breakpoint. We'll run this application up. And we can see at this point, despite writing logout information here, we switch the output window, we're not actually seeing any output. This is because our minimum log level is currently set to error. Let's go ahead and change this to information. And we're going to run our application again. And what we should see now in our output window is that we can see that the development environment has been returned here. Notice here that we're also seeing the method that the log command was executed from. This provides us some additional debug information that's quite useful. The next thing we're going to look at is configuration. What makes it possible to add applications.json files as configuration sources. It also supports environment-specific application settings. For example, appsettings.development.json. It also includes supporting JSON files that as either content or embedded resource files. Configuration supports accessing configuration sections by either associating a section with a particular class. An instance of the register class can then be retrieved throughout the application. Let's go ahead and register the app.info class. So we'll come back up here and specify the app.info class. We can go ahead and retrieve this information later. And in this code, we can see that we're retrieving the instance of the app.info, and we're going to use that to set the title on our application. Let's go ahead and run this. If we hover over here, we should see that this is now set to the UnoConf app/dev. And the reason for this is that we have two app settings files. We've got appsettings.json, where we've got the title set to UnoConf app, or Commerce app. And then we've got the appsettings.development.json, where it's got the dev suffix. And we can see here that because we're running in development mode, this file has taken precedence and is overriding the value set in the default appsettings.json. Configuration also supports writing application-specific settings, which can be made use of by the same mechanism as other configuration information. To make use of a configuration section that's writable, we just need to register the class with use settings instead of use configuration. Come back here and we're going to register a different class as settings. Here we can see that we can make use of the commerce settings, and we're going to be able to use that to persist the last search term that we entered. So let's come back down to our code, down here, and we're going to retrieve a writable options version of the commerce settings, and we're going to use that to specify the last search term. Elsewhere in our application, we can then retrieve this using the same mechanism as we would any other configuration information. So we can specify that here. If we run this up now, we'll see that this last search term is set to the persisted value of shoes. And this will be persisted through different application instances. And we can see that that is set to the value of shoes. The last Uno extension we're going to cover today is navigation, which is probably one of the hardest challenges in any XAML-based application. Out of the box, the platform supports view-to-view style navigation. For example, being able to navigate to a new page in a frame. Other frameworks build on top of this and provide a level of abstraction, such as view-to-view navigation, or simple URI-based navigation scheme. Navigation in the Uno extensions aims to provide a consistent model for navigation that can be accessed from the view model, or even XAML code. The other challenge is that whilst navigation appears to be quite simple, for example, just simply navigating from one page to the next, it's made difficult by the wide array of permutations that need to be supported. For example, navigating to request a value, or navigating between tabs. Navigation is also more than simply navigating forward to a new page or to a different tab. In some cases, it may be necessary to navigate back to a previous view. For example, navigating to the previous page in the context of frame-based navigation. Navigation also needs to support being able to pass values or data between views. There are also scenarios where navigation needs to support selecting or picking a value that's returned to the caller. We took on these challenges and aimed to provide a simple yet consistent model for navigation, whilst also supporting the wider variety of scenarios that are required for a typical application. Our approach to navigation is that an application can be broken down into a series of navigation regions. For example, a frame would be a navigation region. Regions can be nested, for example, having tabs nested within a page that belong to a frame. Note, in this case, the tabs and frame would be navigation regions, but the individual tab items or pages would not. Tab items and pages just represent the current route that has been navigated to for a particular region. Each region has an associated implementation of the iNavigator interface, which understands how navigation should be applied to a particular region. For example, navigation on a frame translates to simply calling the navigate method on a frame itself, which displays the new page, typically moving the existing page to the backstack. For tabs, navigation translates to switching between the tab items. At the heart of navigation in the Uno extensions is the navigate method on the iNavigator interface, which accepts a navigation request that includes the route to navigate to. The iNavigator implementation understands how to translate a route to the specific implementation for a region type. This all sounds way too theoretical, so let's just see it in action. We're going to start by enabling navigation again back on our iHost. So let's come up here and enable iNavigation. We then need to go down and replace the existing navigation logic, so creating a frame, navigating to the login page, with the code that will actually use the iNavigate pattern. So we'll go here, and this essentially sets the content of the window to be a shell view control, which we'll see in a second, and enables it for navigation. You can think of the shell view control as basically being the top level view of the application and contains the first navigation region. In this case, it's going to be a frame. But the thing to note about the shell view is that it's simply just a user control. You can call it whatever you like. There's no logic tied to the name shell view. The only special thing is that it contains a frame where the region.attach property is set to true. If we look at the code behind, you'll notice that there's nothing special there. The only question that might come to mind now is, okay, well, where do we put the logic for navigating to our first page of the application? You know, where's the standard logic to navigate to, or call navigate on the frame? This is all done within the shell view model. An instance of the shell view model is created at runtime and set as a data context for the shell view. You can see the logic here isn't very advanced. All we're doing here is actually logging out the fact that the application starts. So if I run the application now, all we're going to see is a blank page. What we need to do is actually change this to take a dependency on the iNavigator interface and then use that to navigate to the first page within our application. So let's go ahead and do that. So we can see it's taking a dependency on the iNavigator interface, and we're going to use that to navigate by view model to our login view model. Let's go ahead and run the application now. And we can see that we're now going to the login page. However, if I start to type the login in here and hit the login button, it's not going to go anywhere. And that's because in our code here, we're waiting for navigation to complete, i.e. we're awaiting it. And all we're doing here is waiting for it to navigate to the first page. We're not actually waiting for a response back from that page. So let's just change this logic slightly. And this time, in addition to waiting for the navigation to complete, we're then going to await the result. We're then going to validate that the result is actually a credentials object and make sure that we have a valid username. Once we do that, we're then going to navigate onto the home view model, which will take us to the home page of our application. So let's actually go ahead and run our application and check that we can now log in. Now we can log in and we're taken to the home page of our application. If I go to the profile tab, all that, and hit the logout button, you'll notice that again, it's not logging out for us. So the navigation is not actually doing anything. So if we come back to our shell view model, we can update this logic again, and this time await the result from the navigation to the login to the home view model. So we can go ahead and run this application up now. Let's restart this. And you'll notice here that when we're awaiting the result of the navigation to the home view model, we don't care about the response because we're just assuming that by the time this returns, we're actually logged out of the application. So all we want to do really is actually call the start method again and perform the login function. So log out. And now we can log back into our application. Okay, so this is typical logic that you'd imagine in an application. The only thing that we probably would add in a real world application is that in the startup logic, we would actually check to see whether we've got a persisted set of credentials, and thereby the user wouldn't have to log in every time they enter the application. Okay, the other thing that I want to just quickly show is another type of navigation. And so if we click on this filters button, we're seeing that we're navigating to this pop-up dialog. We can specify a filter, hit the apply button, and then that data is then returned back to our application. This is an interesting example because it actually demonstrates being able to navigate using XAML. So if we come down on our products page to our to the button for filter, which is right here, we can see that the hyperlink button, the navigation here is defined completely in XAML. And so we're specifying that we're going to navigate to the filter dialog, and the dialog is specified by the exclamation point. And we're going to pass in a data object. In this case, it's the existing filter value that's being applied to the products list. Similarly, if we go to the filter pop-up page and we come down and look at the apply button, we can again see that the navigation request is defined in XAML. This is a back navigation or closed navigation. Again, the data is specified to be the updated filter value that's specified in the filter pop-up. Okay, so this is an example of a complete round trip of XAML-based navigation without us having to write any code behind. As we can see, navigation is quite a complex topic when you look at all of the different types of navigation controls. For example, frames, dialogues, tabs, pickers, and all the different navigation patterns that need to exist, such as view to view or view model to view model, or even XAML-based navigation. The Uno Extensions navigation model provides a consistent model where the navigation model is the same whether you're invoking it from the view, view model, or XAML layer. It's also extensible, meaning that implementations can be added for different navigation controls. There are some other Uno extensions that we haven't covered today. For example, defining and registering HTTP and refit endpoints, and for example, localization support throughout the application. In this session, we've stepped through a number of the Uno extensions that can help reduce the overhead of building an amazing Uno application. Thanks for watching this session, and feel free to send any feedback to this session or the direction that we're heading with the Uno extensions. Thanks, everyone.
Hello everybody, and welcome to my talk on how we bring features from WinUI to Uno Platform on day 0. We at Uno Platform like to say that we're standing on the shoulders of giants. In this case, it's Microsoft with its Windows UI library, which contains all the features necessary to create beautiful Windows applications. And because Uno Platform has the same API surface, we are then able to take those Windows applications and bring them to Android, iOS, macOS, WebAssembly, and Linux without changing any single line of code. Of course, WinUI is evolving constantly, so we need to keep up with them by bringing all the new features and enhancements to Uno Platform so that we keep that code reuse in effect. Here's an example of free controls that we brought in from WinUI, which were not originally available in Universal Windows Platform. On the left is Tree View, in the center Navigation View with Hierarchy, and on the right is Tab View. All these controls are very complex, so figuring out how they were implemented without having the source code available would be hard. But we are lucky that Microsoft is cooperating with us. They are developing in the open, and they are even giving us feedback on our changes. In turn, when we are porting those features from WinUI to Uno Platform, we are able to contribute back to WinUI when we discover some issues or bugs, which tends to happen because we have multiple different targets, not just Windows. So we are hitting some scenarios which were originally not thought of. Of course, the porting process has to be very streamlined so that it's easy to do and easy to evolve, because all the features in WinUI are added daily, and we have to be able to keep up to be on par with them. So we devised this simple 3-step process, which starts with copying XAML styles and string resources, because Uno Platform has complete compatibility with XAML from WinUI and string resources in ResW files. So we can just take those files one-to-one to our code base. Then we port the C++ code, which is in WinUI, to our code base in C#. So this part of the process is the hardest and lengthiest because it involves a semi-automatic conversion of that C++ code to C#. It's not that hard because we have a simple tool that replaces a lot of common patterns in C++ to C#, but still it requires some manual work. Finally, when we have the code ported and the control is up and running, we can port the API and UI tests so that we can ensure that when in the future we add more features, that we don't break the existing ones, or in the future when the control is updated, we can verify that the existing functionality of the control is unaffected. So to demonstrate how this all works, and maybe to inspire you to also port some WinUI control to Uno platform, let's look at how we did this with the WinUI tab view. I will go here to my desktop and open two instances of File Explorer. On the right side, we will have Uno Platform's code base. And on the left side, we will have Microsoft UI XAML controls code base. In there, I will navigate to Dev and Tab View. And on the right, I will also do the same thing. So Uno UI, Microsoft UI XAML, UI XAML, controls, and Tab View. So you can already see there is some striking resemblance between those two windows. And I will go through the process starting with the simple things, that is string resources and XAML styles and templates. So string resources are in this strings folder. And as you can see, it contains strings for various languages. Commonly, it's like tooltips and translation strings for buttons and so on. So you can see it's just a simple resource dictionary with some translations for common things. Because we completely support ResW files in Uno platform, we can just take this whole strings folder and copy paste it into our code base. So this folder is identical to this. Next up, we would take the XAML files. And XAML styles are fully supported in Uno platform, so we can also take those one-to-one. But there is one catch, and that is that Uno platform supports both the old version styles from WinUI 2.5 and earlier, and new styles that are matching Windows 11 styles. And in the code base of WinUI, those are in this same folder. But in case of Uno platform, we have a special project for both of these versions, so that you can then use the linker to link out the version that you're not using. So in case you're using Windows 11 styles, you don't have to include Windows 10 styles and earlier in that specific application. So for V1 resources, we put those here in the resources, version 1, priority default, and you can see there is tab view and tab view theme resources. So that's matching these two. And for the V2 version, we have this folder here. So resources, version 2, priority default, and we go here into tab view and tab view theme resources. So these are the same as this. So that's pretty simple. And that covers the first part of the porting process. Next up, we have to port the source code. And for that, I will first return to the tab view folder in Uno platform here. And now I will actually open this IDL file on the left. IDL stands for Interface Definition Language, and it's used to describe COM objects in Microsoft technologies. And as you can see, this file actually describes the public interface of the tab view control at all its related classes. So there are some enums, there are some event arcs classes, there is the control itself, the tab view, and there is tab view item and tab view item template settings, finally tab view list view, and some automation peers. So when porting, we start with the simple things, which are the enums and event arcs. And you can see we have those here. So for example, the tab view with mode can be ported pretty easily by just copying from the IDL file to a C# class and adjusting the syntax. Of course, for these simple classes, we can do it by hand. But when we go to more complex files, like the tabview CPP file, that's far more complex. As you can see, this is plain C++ code, which might be unfamiliar to C# users. And it has a lot of additional syntax like double colons, prefixes like WinRT. There are some specific C++ approaches like append instead of add, and so on. So all these things are different from C# and are not compatible with C#. So we have to do this by hand and adjust this code so that it works and compiles under C#. Because porting this whole thing manually, you can see that's and so it's more than 1000 lines of code, and it's just one file. There is also tabview item and tabview list view. Porting all this would be a lot of manual labor. So instead of that, we have created a simple tool which allows us to replace quickly some common patterns in the code. This tool is essentially just a list of regular expressions that are run against that file and are replacing some patterns with some substitutions. But it's quite powerful actually. So if I run this against the tabview file, you will actually see that now the file is looking much more like a C# code. So if I put it side by side, you can see that many things from the left have been replaced by something more familiar. For example, here we have the loaded event, attaching the loaded event. We have actually the attachment on C# way. And the same thing for other things like the double colons are gone now instead of replaced by dot, and so on. So this actually improved the code in C# manner a lot. But still, there is a lot of things that the developer has to do manually. For example, we cannot know that key is actually a property, but it's actually a property, so we have to do this manually. So instead of this, I would do afterwards this, the same thing here, and so on. So these adjustments are quite simple. It can be done manually, but it's hard to automate them because we don't know actually if this specific thing is a method or property or event. So these adjustments need to be done by hand. I can take an example here. For example, this method updates scroll view, decrease and increase buttons view state. You can see that compared to the original version, it's already much more familiar to C#. So it's using this is syntax to check for nullability, and there are some things already converted, but you still have to do this instead of this. Now apps is a math apps method, and that would be it. So the conversion took just a few seconds, but it has to be done for the whole file. So for a complex control like tabview, which consists of multiple classes, this could take several hours to finalize and fully clean up all the errors and potential warnings. So let me just open the final version from the UNO platform codebase so you can see the comparison between the intermediary state and the final state. And as you can see, this is all cleaned up. And for example, for that method, let's see how it's called here. So for that specific method, you can see that's the changes that I did are now applied, and this is what compiles under C#. So after you perform all these changes for all the C# files and convert all the C++ to C#, you are basically ready to run the control against UNO platform targets. So of course, the easiest way to check for the functionality is to create some sample XAML page that demonstrates that the control actually works. And for that purpose, WinUI provides this test UI folder, which contains some sample pages that you can use to test that control. So these are just simple plain XAML C# pages which contain some XAML and the control itself, and verify some functionality. I can actually show this to you in the official WinUI sample application. So this is the TabView page, XAML page. So this shows some behavior and functionality of the TabView. And we can actually take this page as it is and copy it into Uno platform. So if I go to source samples app, which is our sample app on which we test our new features, and go to UI test shared, Microsoft XAML controls, and TabView tests, I can see that all these sample pages are already part of our code base. And I can actually show you that in our sample application, we have those samples here. So I can click on one of those, for example, TabView page, and you will be able to see the exact same UI as you just saw in the WinUI sample application. So that's very nice because it allows us to see that the conversion and porting actually worked. And it allows us even to check for dark and light theme. So if I switch to dark theme, now the TabView is showing up in dark theme. So that's for the manual testing. And the final step is to actually automate this testing so that we know that in the future, we don't break the control by adding new features or changing some infrastructure. So I will go back to TabView folder and in here also. So let's go back to Uno UI, Microsoft XAML controls, and there's TabView. And on the left side, you can see there are some API tests. And these API tests are essentially unit tests that test some simple functionality of the control. Usually it's default values or some basic behavior of methods and so on. So these runtime tests are written using MS test framework. And because we are using MS test framework for our runtime tests, we can essentially just take this code and copy paste it into Uno UI runtime tests. So if I go here into TabView and open the test, so I can see that this code that we saw before is also here, although this doesn't include all the tests because some of the functionalities are not yet supported, for example, keyboard input. But in general, the tests are very easy to copy because they are just the same infrastructure, the same API surface as we have. The more complex tests are the UI tests. And for the UI tests, Microsoft is using the pages from test UI and running some UI tests against them. So if I open this is the test suite that is testing the TabView. And these tests are usually very complex. And they are testing rigorously all the functionality and features of the control. And because Microsoft is using their own Windows UI testing library, it's not really easy to port those tests directly. We have our own UI testing library called Uno UI Test, but that's based on Xamarin testing framework so that it can reach Android, iOS, and WebAssembly. And we have to port that code from WinUI to Uno Platform's syntax. So if I go here into Samples app UI tests, and Microsoft UI XAML controls, you can see that we have a set of tests based on what we saw here from Microsoft. Although it has a little bit different syntax and some parts of it are commented out. Usually that is keyboard input, which we cannot simulate on mobile devices, and also gamepad input, which we also cannot easily simulate. So maybe in the future we will be able to do that, but for now we comment out these part of the tests and just verify what's possible to verify. So that would conclude that porting process. And after that, after we do this, we have a rigorous test suite that we can run for each commit into the master repository. And we can verify that our changes don't break existing controls and new features are also well tested. one more thing that I want to show you before I finish is how we make sure that the control stays up to date. So I will go back to Microsoft UI XAML controls and to the tab view, and I will open this one, and you can see that for each C# file that we port, we have this commit ID on top, and that helps us to identify the changes. So if I go now into Microsoft's open source repo of WinUI, and I go to dev, tab view, and open the tab view CPP file, and I look into history, I can see that since we ported the control, there has been one new change, one new commit. And when I click on this, it actually shows me for that specific file, all the changes that happened for that specific file. So we are able then to very easily find the lines that have to be changed and just do those changes and update the control. So updating existing controls when done regularly is a question of several minutes, because for each of the files we just go through what has changed since the last time we ported it. So that's very efficient, and so the initial porting, which takes longer, that allows for easy porting of new features and updates. And with that, I thank you for your attention, and I hope you've been inspired at least a little bit to contribute to Uno platform and maybe even try porting some of those WinUI controls that are currently being developed at Microsoft's side. And we are always welcoming new contributors to Uno platform. So we are happy to have you. Enjoy the rest of UnoConf, and thank you.
Hello there, my name is Darren May. I'm a developer, trainer, and Microsoft Windows Development MVP. Migrating from desktop-based applications to the web by using the Uno platform is reasonably straightforward. In this short session, we will cover some of the architectural fundamentals and implementation considerations for migrating WPF applications to the web using the Uno platform and WinUI. In this session, we'll talk about how to get started, some aspects of scoping the migration, as well as some implementation considerations for WPF XAML to the modern XAML, and then we'll demo a migrated application. So let's take a look at preparing for a migration. When I'm thinking about a migration, my key concerns are going to be around how do I maximize reuse, not only of the code, but also my existing skill set. That's where the Uno platform really shines. If you've invested in C#, XAML, and .NET, this is a natural place to go. When I'm thinking about migrating a code base, I typically think about three things. I want to maximize the reuse of the code. I want to refresh where it makes sense if I want to exploit new capabilities in the platform. And I want to rewrite as little as possible. Pragmatically, that looks something like this. Vast majority of your code base is going to move across, be that the existing XAML structure, as well as things like business logic and view models and so on and so forth. You are going to have to refresh some things. For example, navigation has changed a little bit between the platforms, and equally we have access to more advanced binding capabilities using Xbind. And there's also going to be some areas that we're just going to need to rewrite. That may be that we have a custom control that leverages specific deep features of WPF that don't exist in UWP. The important thing is to perform your research first. The Uno platform's application API is compatible with the UWP application API as well as WinUI 3. And it's important to understand the capabilities of those platforms. There are some differences between them and the existing .NET Framework libraries. So if you want to use older code, you're going to need to recompile it, and you won't have access to framework-only APIs. The other key thing to think about is a lot of the modern APIs are async only. So if you've made use of synchronous code in your previous WPF applications, you're going to have to take a look at what it's going to take to migrate over to a more of an asynchronous task-based model. In terms of XAML, there's a lot of compatibility between them as they share a lot of common roots. However, some of the more advanced flexibility features in WPF XAML have been dropped in favor of more performance in the modern XAML. The other thing to take into account is the Uno platform has migrated a lot of the APIs over. However, some of them are yet to be migrated, and some of the controls have been migrated with only a few of the available properties. So dig into the documentation. There's a lot there that talks about how to get started and how-tos and so on. But make sure that you have a concrete idea of where you're trying to go and what controls you're trying to use. The key point here is to understand what is supported before you dive in and start building. So now we've got an understanding of what the Uno platform has to offer from a high level. What are the considerations when migrating your app from the desktop to the web? Well, in terms of architecture, we need to think about, okay, how was our existing application built? Did we use MVVM? If so, was it an in-house variant or was it some third-party library? There's great news there in that many of the third-party MVVM libraries have been migrated over to Uno, such as MVVM Lite, Prism, and there's also an existing implementation available in the Windows Community Toolkit for use if you should need to start from scratch. Of course, you can still leverage code behind. The other thing to consider is the navigation style in your previous application. If it was using page-based navigation, great news. That's relatively straightforward to migrate, although there are some implementation changes that you need to take into account. Another area of investment is a lot of custom controls. So you're going to need to look at, okay, how do I migrate those things over? Is there an existing built-in platform implementation of this control that I can leverage or be better to use? Are there controls available in the Windows Community Toolkit and so on? Also good news, a lot of the WPF applications leverage content controls and data templates to give a lot of variability in the UI. That is still supported over in the modern XAML, although you might want to consider migrating your data templates over to more strongly typed variants to take advantage of the performance that Xbind gives you. As I mentioned earlier, we also have the asynchronous pattern that we need to make sure that we're adopting as well as we can. Other things to consider, data access. Many of the smaller WPF applications are often directly connected to databases. You need to consider whether that's still a good pattern to employ. Doesn't really make sense if we're migrating to the web, so we want to look at leveraging web services and so on and so forth. We also need to look at our application. Has it leveraged things like WCF or WCF data services? Unfortunately, those technologies are deprecated, so we might need to consider migrating to gRPC or REST-based services. And a final area to think about is tight desktop integration. You might be leveraging registry access or settings files and so on and so forth. Those things aren't going to be available to you if you migrate over to the web. So now we've looked at architectural considerations from a high level. Let's think about how we can look at some of the WPF XAML features that are missing and some alternative approaches for implementing those features. So there's a great deal of compatibility between WPF XAML and UWP XAML, but some of those features that provided a lot of flexibility have been sacrificed in the name of performance. Particularly if you're looking at binding, multi-binding, priority binding, and the ability to access an ancestor element, those aren't available out of the box. There are workarounds for those things in terms of behaviors that have been provided, but also Xbind provides a lot of opportunity with function binding and so on. Some of the more dynamic styling capabilities that style triggers and dynamic resources aren't available to us. Style triggers, for example, are not available. Dynamic resources not available, but there are workarounds for these. An area where there isn't many workarounds is the XAML extensions that provided access to change code generation, such as class modifiers, subclass, and so on. And an area that may particularly bite is if you've made a lot of use of xnull in setting up bindings. That isn't available in UWP. Of course, there are differences in the controls that are available out of the box. For example, WPF has a label control. That isn't available in UWP, for example, but TextBlock is. Also, many controls have built-in header properties that you can leverage instead of label anyway. Things like listbox have been deprecated. It is available in UWP, but list view is now preferred. Data grid isn't implemented out of the box, but is available within the Windows Community Toolkit. I strongly recommend looking at the available resources for the different controls that are available in the platforms, as well as Community Toolkit, and I've left links on this slide that you can go and follow. Now let's take a look at a couple of examples of multi-binding and how we can implement similar capabilities in the modern XAML. So in WPF, we have this string format capability in a multi-binding, which allows us to take more than one binding for, in this case, last name and first name, and then construct a string that gets rendered up as a single text block. How would we approach that in modern XAML? Well, we have the advantage that text block actually allows us to bind to run elements within there. So as you can see here, we have 3 run elements, 2 that are bound to properties and 1 that is just dropping out the comma and a space. And so that achieves the same result. But of course, there's more than one way to achieve this. Xbind also introduces the ability to use function binding, where we can have a function implemented in a code behind, or if we're using MVVM in the view model itself. And that allows us to pass binding values, or in fact string literals, into that function to return back similar results. Another aspect of multi-binding is the ability to be able to leverage values from multiple controls and generate a single value out to, in this example, to use the sliders red, green, and blue to change the fill property for the rectangle. If we look in WPF XAML, then what we have here is we have a color converter resource that's declared. Then we have the UI layout, and you'll notice we have sliders and labels, and the sliders are named. And then finally, we have a multi-binding that's setting the fill property of our rectangle. And what we can see there is the multi-binding is monitoring the values of the sliders and passing those into the color converter control resource in order to generate a new color for our rectangle. That converter looks something like this. As you can see, the convert method actually receives an array of values. Because this is loosely typed as an object, we need to make sure we perform some validation and make sure the values are not null, that they're not unset, and so on, before we convert them over to byte values from which we can then generate a color and a solid color brush. So how does this look like in UWP? Well, as you would imagine, the UI looks very similar. The XAML is a bit simpler. We actually don't have to have a custom converter defined, and our sliders have built-in header properties, so we don't need the labels. If we take a look at the fill property, we can see that's using Xbind to use a function from values where we can pass in the strongly typed named values from our sliders. if we look at the actual function, we can see that's a lot simpler as well. Because this is strongly typed, we're getting doubles for our values, so we can use those directly in the generation of our color and our solid color brush. Another area that we're missing from WPF is style triggers. So if we look at style triggers, they basically are used to change control properties based upon values or expressions, and they're also used to respond to system theme changes. For example, if we want to display a high contrast version of our UI. UWP has a lot of alternatives for these, of which style selector is probably the most common you'll use. Another area that is particularly useful in responding to theme changes is theme resources. So here's an example of a WPF UI that is using a style trigger to change how items are rendered in a list. In this particular example, any city that is in Washington state is going to be rendered with a foreground of red, and the particular instance of Portland, Oregon is going to be rendered with a cyan background, and everything else is going to be rendered with a default look and feel. So in WPF, we might have a style trigger that looks something like this. We have a data trigger that's monitoring the value of the state in the context. If it's Washington, then it's going to set the foreground to red. Then we have a multi-data trigger that is using two conditions. One is the city equal to Portland, and is the state equal to Oregon. And if so, it's going to set the background property to cyan. In UWP, if we're going to use a style selector approach, we need to have multiple styles, one for each of our scenarios. For example, we've got the Washington style that has a foreground of red, and then we've got the Portland, Oregon style that has the background of cyan. We then create a static resource using a custom selector, and we pass in those two styles. In terms of implementation, it's pretty straightforward and looks somewhat similar to the logic we expressed in our data triggers. We're implementing from style selector. We have our two properties for our various styles, and then we're overriding select style core, which is then evaluating our business logic. We're getting passed in the type that is being displayed. So we've got item, we're casting that over to our city state, and we're then checking the values. If the state is Washington, we're returning the Washington style. If it's Portland and it's Oregon, then it's going to return the Portland, Oregon style. Otherwise, it's going to return the default style for the item. In terms of how we would use this, for example, here's our list view. We have a attribute item container style selector, which we can specify the custom style selector we want to use. And this will render out the same output as we saw in WPF. Coming on to themes, themes are a very powerful capability in modern XAML. So in our WPF application, by default, it would look something like this. And if we switched our system over to high contrast, then the theme would change to display this sort of content. In terms of the WPF implementation, we've got a style trigger here that's looking specifically at the header style. And you'll notice we've got style triggers and a data trigger that is monitoring the system parameters high contrast. If that gets set to true, then it's going to change the values for the label foreground and background to use system colors. So how would we go about approaching this in UWP? Well, UWP has this concept of theme dictionaries, which are a collection of resource dictionaries specific to a particular theme. In this example, we have 3 dictionaries for dark, default, which matches our light theme, and high contrast. Within each of these dictionaries, we've specified the same resource but different color values for it. For example, white on our dark theme, a blue color on our light theme, and then we're leveraging another theme resource, which is a predefined system color button text color. That ensures that we're maintaining our best practices around having high contrast colors. In terms of how we would use this, we'll have our style again for our header text style, and instead of specifying a static resource, this time we're specifying a theme resource which will be updated dynamically should the system theme change. So as an example, here is our WASM version of our application running in light theme, and then the system's been switched to high contrast, and we can see the colors have changed. But of course, we also can support a dark theme, and so our dark theme looks somewhat similar to the high contrast in terms of colors, but we have a much richer color palette available to us. So that's enough of the slides. Let's take a look at a migrated application running in WebAssembly. So let's take a look at the WPF application that has been migrated. Very simple. It's a straightforward 2-page application, uses the navigation frame, has a list of users. I can select a user, hit view, see the expense report for that user, and hit the back button to return back to the home page. Let's now have a look at the Uno version of this implemented as UWP. So as you can see, very, very similar UI. We have a list of users. I can select view, navigates to the expense report page. I can hit back and return to the home page. You may have noticed as well that there are transitions as I navigate between pages and as these items load. Now let's have a look at the same application running as WebAssembly. Open up my browser, browsing to a local source, splash page, and so again you can see a lot of consistency between the look and feel between the WebAssembly version and the UWP version of the migrated Uno app. I can select a user, hit view, see the expense report, see the information loaded, and hit the back button to navigate back. One thing you may notice is that transition animations between the views isn't supported. Now let's have a look at the Visual Studio solution that supports this. In my solution, I have 2 solution folders, one for the original WPF application and one that contains the Uno projects. WPF application was created using the .NET framework, could just as easily be .NET Core, very, very similar. Down here we have 3 projects. We have the shared project, which is where we do most of the work for migration, and we have our 2 heads, one for the Universal Windows application and one for WebAssembly. If you were using WinUI, you would have obviously a Windows desktop target, and also by default you would have other platforms such as Android, iOS, macOS, Tizen, and so on and so forth. I've deleted those because they're not relevant to my particular scenario. If we have a look at the actual structure of the WPF project, we can see we have AppXAML, which defines the application. We have 2 navigation views, Expense at Home and Expense Report page. We have a main window which provides our Chrome for navigation. We have a styles dictionary, and we have the watermark file. If we come down to our shared project in the Uno project, we have a very similar structure. We have a few additional folders. We have assets, which is by convention where we put things like our watermarks and so on. I have a models library, and I'll come back to that in a moment. I have services. This is again something that I've added as a place to encapsulate where my data is. We have strings, so this is created by default and is a resource table for strings. And then we have our main application structure. So again, we've got our application definition, we have our 2 navigated views, and we have styles. When we look at the application XAML for WPF, what we see is it's pretty simple. We have a startup URI that tells the application that the first view to be displayed is main window. We also merge in our styles dictionary. Comparing that to the app.xaml in our shared project, it's very, very similar. We don't have a default URI because we're actually going to direct that in code. But again, we merge in our resource dictionary as well as the WinUI styles. If we have a look at the code behind for the WPF app, what we see is it's effectively an empty template. All of this startup is specified declaratively in the app.xaml. Of course, there's many things we could add to this, and in most non-trivial applications, you would have things in here for startup and so on. If I look at the same file in our shared project for Uno, we see there's a lot more code in here. Now, of course, I didn't need to write all of this. This was actually part of the boilerplate that's provided when we actually create an Uno project. It has things in here that detect different platforms and so on, because obviously this supports multiple targets. It needs to be able to support startups in different platforms such as Android, iOS, and so on. The key area I want to show you right now is during startup, we get hold of our current window and we look to see whether its content is an existing frame. That would be the case if the application was already running and we were re-entering a running application. If not, we create a new frame. This frame performs a similar purpose as the main window on our WPF application and is the host of our navigation, if you like. Once we have our frame, this is how we actually navigate to our homepage. So this basically says root frame navigate to the type expense.it home. The infrastructure behind this creates an instance of expense.it home and displays it. So there's a little bit of difference on how the application starts up. Now let's have a look at the expense.it home in the WPF application. If we take a look at this, we can see its overall structure is pretty straightforward. We have resources, we have our grid that's defined, which defines our layout of columns and rows, and then we have the controls that are displayed within. If we look at the same page in our shared project, we can see a very similar structure. If we collapse down our resources, we've got our background image, we've got our layout definitions, and we've got our controls. Now we are using text blocks instead of a label, borders the same, we're using a list view instead of a list box, button is the same. So you can see how a lot of this layout code can be copied straight over from the WPF application into our shared project. If we come back to the expense.it home, in the resources, we do have something that isn't available in UWP, which is the XML data provider, and we're using XData to specify XML that defines our displayed data. We can do something very similar in the UWP XAML by using the fact that XAML itself is an object instantiation framework, and we can specify our objects and supply properties and so on. These models have to exist as classes, and they're defined in our models directory. So we could use this as an alternate approach to achieving something similar in terms of embedding the data within our XAML. I personally don't really like this particular approach. I prefer to have a separate service that has my data in it. So this is just a simple class that has a static list of data that I can then bind to. But your mileage may vary. Now let's have a look at the styles. So if I open up the styles dictionary on the WPF side, we can see that we have this definition of a header style. We actually have many styles in here, but we'll just focus on the header text style. So taking a look at the header text style, we can see that we have setters for label, vertical alignment. This is because this style isn't targeting a particular control, so we're specifying the type of control here by saying label dot. In our UWP styles resources, we're always going to be specifying our target type, so we don't need to have this, and actually this isn't supported as a dot notation. We then specify things like our colors, and then we have this style trigger that we mentioned earlier in terms of responding to system theme changes. If we look at the styles in our UWP application, we have our resource dictionaries that we're using for themes. So as mentioned earlier, we have the ability to specify resources that change depending on whether we're dark theme, default theme, or high contrast. I like to centralize my resources into specific colors and then give them useful mnemonics that I use throughout my styles. But here is the UWP equivalent of the header style. Notice it's targeting a text block, so we don't have text block.vertical alignment and so on and so forth. And then we're specifying a theme resource for our colors. This makes it theme responsive. So let's have a look at our applications running again and see what happens when we change our theme. So if I bring up the system settings, I can change our theme from the light theme to the dark theme. So I'm going to click this, and we can see that immediately our web application has picked up our changes. We can also see that our UWP application has now picked up the changes. And of course, WPF has no concept of the dark theme, and so hasn't changed at all. I hope this gives you some insight into some of the capabilities that are available using WebAssembly with the Uno platform. In this session, we've looked at migration concerns, key aspects of reuse. We've emphasized the importance of research and how that plays into looking at our existing architecture and coming up with an architectural roadmap of moving forward. And then we've looked at key aspects of XAML compatibility on migrating your application over to the Uno platform. Thanks very much for watching.
Hello everybody, I'm Daniel Kauser. I'm a software developer and a Microsoft MVP. I am passionate about everything related to mobile development, and I'm super excited to be here today talking at the UnoConf 2021. Our industry has many different flavors of frameworks for us to pick and choose. But the frameworks that gives us flexibility are the ones that are true successful. The ones that empower us developers to do what we need to do. This is what we'll discuss in this presentation today, how flexible the Uno platform is when it comes to giving us the tools that we need to get our jobs done. I believe everyone is used to this picture here, but I think it's important to highlight the fact that Uno through .NET has access to all the native ecosystems of the platforms that we want to target. The goal of this presentation is to show how we can use these native APIs on our Uno apps. So to do that, we'll create a barcode reader app. This app will target two platforms, Android and the web. On Android, we'll use the Zing mobile library to read barcodes. This is a library available on the .NET ecosystem. It has implementations for Android, iOS, and other platforms. So our Android app will basically have a view with a button that a user will click and will be redirected to the camera of the phone. And the camera, using the Zing mobile library, will scan for barcodes that show on the camera feed of the phone. Now for WASM, we'll use Quagga.js. Quagga.js is a JavaScript library, and we'll import it to our Uno project. And with the aid of Uno helpers, we'll work with JavaScript on C#. So first, we'll have to create a HTML5 video tag that will load the feed of the webcam on the web page. After that, we'll import the Quagga.js library into our project so that the Quagga.js can start scanning our barcodes from our video feed. And third, we'll actually see how to invoke C# code from within JavaScript. So demo time now. I am gonna open up Visual Studio. And first, we are going to target the Android demo first, and for that we gonna start by adding the Zing mobile library to our project, to the head projects that have implementations for this library. So let's go ahead, search for the library on NuGet. I believe I already have it installed for Android and iOS, but let's go ahead and reinstall on also UWP, just to show that this library has the proper implementation for the three platforms. Okay, so here we are. We have installed it, and next we need to add permissions to our Android projects. So the Android will need the camera permission as well as the flashlight permission. Let's go ahead and save. After that, we also need to start up the library on the main activity of our Android project. All right. Okay, so IntelliSense is happy. So let's go ahead and go to the Uno shared project, and here we have a basic MVVM setup. We have the barcode reader service, we have a main page view, and the main page view model. All right, so we are going to go ahead and add a contract to our interface that is going to be the one that reads the barcodes. Let's add the usings on the page. And next, let's go to our view model and add the required code for the view model to call our method from within no service. This is going to be an async. And after that, assign the value of the barcode to a local property that is binded to our view. Now, next, let's go to the implementation of our service and add the required usings for Zing Mobile. And let's also go ahead and add the implementation of our class, of our method, right? So here we are targeting Android, and also UWP here. We have the compiler directives. So we are literally calling 2 lines of code to be able to show the camera and handle all the complexities of the flow of reading the barcode. I am gonna be scanning barcodes from this phone. It's simpler for me to place the iPhone in front of the Android and make sure that it's actually reading the barcodes. So let's go ahead and build and deploy to my local Android phone that I have here on my setup. And right now the Android phone is pointing to the screen of the iOS phone that contains the barcodes that we're going to read, right? So while we wait, I think it's good to see that and to know that Uno runs on .NET, right? So we have access to the extensive ecosystem of libraries and tools available on .NET to our Uno apps, right? As long as they have the implementations on the targets that we are pointing to, we have everything that we need that exists nowadays on the .NET ecosystem, right? So our app is currently building. I am also gonna open up Visor, right? Is where we're gonna actually see, and you can see here the screen of my phone, of my physical Android phone, and voila, we can see that the app has a button, and when we click on this button, the camera will open up and the value of the barcode will be shown on this barcode value here text box. So let's go ahead, click here, and you can see that it did scan the barcode and it was quite quickly. So let's go ahead and open a different one with a different result. So let's go ahead and voila, we see that it also has understood that the barcode has this text, right? So wonderful. Let's go ahead and move on to the next step, which is targeting the web. So I'm gonna undo my changes over here. And let's check out a different branch right now that will contain the starting code for our WASM demo. Now, for the next demo, I want us to take a look at the HTML5 component that we're gonna have to create. So it's called barcode scanner right here on the Solution Explorer. And we are gonna see that it's basically like a dummy class that has this method over here that we are gonna cover in a little bit. So let's just ignore it for now. We are gonna tell Uno that this is a control. So this is a UI component. And let's also go ahead and decorate this component with some attributes. So these attributes are basically to tell Uno that this component is going to be a div. And on the constructor of this class, we are gonna call a Uno helper that will allow us to create a child component to the div. So we are creating a video tag, and this is where our camera feed is gonna show on the web page. Now we have to go ahead and add our component to our view. So we are gonna open up the main page view, and I'm also gonna add a conditional prefix here that I only want to compile this component if we're targeting the web, if we're targeting WASM. So let me go here on the stack panel and add our component over here. It's going to be displayed below the text box that pops the barcode information on the screen. Now, back to our barcode scanner, we also need to execute some JavaScript to basically be able to start the feed on the web page, right? So I am gonna add here a init JavaScript method that executes some boilerplate JavaScript to let to grab the video element that we just created and start the video feed there. And as well as we need to let the control know that when it's loaded, we want to init the JavaScript, right? All right, now that our component is created and it is properly displaying or capturing the camera feed, we also actually have to add the Quagga.js library to our project. So I have Quagga.js file over here. So we are going to go ahead and add it to our WASM project in the WASM script folder. And we are going to also need to change the build action to embedded resource. All right. Saving. Now, Quagga.js requires some, again, configuration or boilerplate code to start up or to be configured. So we are going to go back to our barcode scanner component, and we are going to add that boilerplate over here. So we have a Quagga init that we need to do, and as well as we need to hook up the own detected event that Quagga raises once it detects barcodes from our camera feed. We also need to execute this JavaScript. So I am going to use this Uno helper here to execute JavaScript. And we are literally sending it in the string with all of the JavaScript that we want to execute. Now, finally, we need to go to our barcode reader service. And in here, we are going to let it know that when it's compiling on WASM, we actually also want to start the Quagga library. So we need to start or let Quagga know that it should start looking into the video feed for possible barcodes, right? And this again is a Uno helper. We have many Uno helpers that we can utilize from our C# code. This is one of them. You can also execute or run asynchronous JavaScript as well. So this API is pretty powerful. Now, going back to our demo, we are gonna target WASM, and we are gonna build it now. And let's go ahead and hit play. The WebAssembly app is being built. The binaries are building. The build has succeeded and it deploys the browser. Now the binaries are being uploaded to the browser. And finally, our application is being loaded. And we are going to be able to see the video feed showing. And voila, here I am. So let's also open the console app, and we are going to be able to see here the logs that Quagga.js dumps into the browser log to let us know that it's configured and it has started up. Now I also want to show here that on our app we also have the Quagga.js library available to us. Wonderful. Okay, so let's go ahead on the console, clear it up, and start scanning barcodes. And I am gonna pick my phone once again and pointing into the direction of the feed over here. And it should start detecting it in a little bit. And we can see on the console of the browser that it has detected some text. Yeah, and it has detected it again. Now we are only showing the information on the console. We are not actually showing the information on the text box that we have on the page. So let's go ahead and fix that. For that, we have to invoke C# code from JavaScript, right? Because it's in the JavaScript that the Quagga.js library is raising this event. So let's start by adding some code over here that will actually dispatch an event, a custom event called barcode detected. All right, so this barcode detected will take in the result information that Quagga.js gives us here when it raises the onDetected event. So now we have to let our component, our UI component, know that it should also register a HTML custom event handler. So for any time that the barcode detected is raised from JavaScript, we want to raise as well the C# event that we have here, which is that first method that we had on our component here, on our UI component class. And basically what it does is it's sending a message to the view model that the barcode has been modified or the value has changed and it should update the view, right? So let's go ahead and save everything and deploy once again, build and deploy once again our web app. So now it's building and it's been built, it's being deployed to the browser, our DLLs are being deployed. And it's loading our application. And voila, we have once again the video feed. Let's open up the console and actually go ahead and try to scan the barcode once again. Oh, but first we need to click on this scan barcode button, right? Because that's what starts it up with Quagga.js. It did detect it, but it didn't quite grab the value. All right, so we can see once again that the barcode value has been detected from the barcode that we just read, and it actually also populated the information over here. All right, so thank you very, very much, everyone, for watching my presentation. I hope that I was able to send a message and show within my demo how flexible the Uno platform is to use the .NET ecosystem, but also Uno gives us tools that allow us to use JavaScript libraries that are out in the open, and we can make use of them and giving us the flexibility of working with whatever and whichever libraries and tools that we need on our projects. Thank you very much and enjoy the rest of the UnoConf.
Hey everyone, Brian Lagunas here, and I hope you are all enjoying UnoConf just as much as I am. You know, I always get excited whenever Uno Platform decides to do an event like this because it gives them the opportunity to showcase and highlight all the new features and tooling and all the innovations that they're making for Uno Platform. Well, not only that, but it gives me the opportunity to tell you about the partnership between Uno Platform and Infragistics. Now, if you're not familiar with Infragistics, Infragistics is a company that builds mission-critical, high-performing, feature-rich line of business UI controls for you to use in your own application. Now, I'm excited to announce that Infragistics has been building a brand new product called the Ultimate UI for Uno Platform. Ultimate UI for Uno Platform is a set of UI controls for you to use in your own cross-platform Uno applications. So say, for example, you're building a cross-platform Uno application and you need a data grid because you have, let's say, 1 million records that you need to render in your app, and you need editing and sorting and grouping and filtering and all these great features that a data grid has. Well, what are you gonna do? You're gonna build your own data grid? No, you're gonna use the Infragistics Ultimate UI for Uno Platform data grid. Need charts? No problem. We got like 60 of them. Pick one. I'm sure we got you covered. Now, the best part about this new product, Ultimate UI for Uno Platform, is that it's free. That's right, it's 100% free. It's freely available on NuGet right now. Now, I know what you're thinking. You're saying, well, Brian, what's the catch? Well, there is a catch. The catch is that Ultimate UI for Uno Platform is in preview. What's that mean? It basically means we're still working on it, right? We know things are missing. We know there's some features we need to implement. There may be some bugs, but we're working on it and we're improving it every day. We're trying to make it better. And this is where we need your help. We need you to go to bit.ly/ig-uno, download the product, build an app with it, add it to your existing Uno application, and give it a try and let us know what you think. Well, have a great day, and I hope you enjoyed the rest of the event.
All right, hi everyone. My name is Steve Belogan. I am an engineer on the Uno platform team, and I am excited today to get to share with you how you can start building beautiful Uno applications using the powerful styling capabilities from the platform, as well as ready-to-ship themes that can transform your app with just a click of a button and a few lines of XAML. So the first thing that I want to do is sort of give us a peek under the hood of how we can all see how styling works in the Uno platform and what it means to be able to deliver pixel perfect applications while still being truly native to whichever platform that you're targeting. Next, we'll dive into the world of Uno themes, and we can take a look at some of the beautiful collections of styles that we provide either out of the box or as a secondary NuGet package. And lastly, I will take a look at how you can customize these themes to match your own branding, as well as building your own theme from scratch. So let's first take a look at how styling works on the Uno platform and what tools are available to you in order to change the look of your app to whatever you like. When we talk about being able to deliver pixel perfect styles while still maintaining the native richness of whichever platform that you're targeting, what we're talking about is the use of templated controls or lookless controls. So now, as you know, Uno Platform is taking those WinUI APIs and bridging them over into completely new territory by having those same APIs work across many different platform operating systems and devices. And so as a result of this effort, it means that we brought over WinUI's extremely powerful styling engine and made it available on each of our supported platforms. And the holy grail of this styling engine is the idea of templated controls. Templated controls are UI elements that have a visual structure and a visual behavior that can be changed and edited using XAML. So we all know that controls have many properties such as background, foreground, font family, etc. And you can set those to specify different aspects of your control's appearance. But the changes that you make with these properties are limited. you can specify additional customizations by creating a template using the control template class. So when you create a control template, you're actually combining lower level framework element objects to build up a single control. So within that template, you get down to the nitty-gritty details. You get down to those primitive shapes and elements whose combination of objects make up a control's visual structure. So looking here on the right, we see we have 3 different controls that have had very different templates applied to them. When you dig down here into this, the toggle switch, the progress ring, the button that we have here, when you dig down, what you're actually looking at are the native controls for whichever platform that you're building for. But thanks to control templating, they look and they feel vastly different from one another. So we could look at a small example. If we open up, let's go on iOS. This is an Uno app on iOS. Let me uncheck these. So we'll zoom in. This is basically just 2 checkboxes. So the default checkbox with the style that's coming straight from the Uno platform, and a style checkbox that I edited. And you can see, it has a circle for the check area rather than this rounded off square. And if we were to check it and zoom back in, you'd see that, we get the normal check glyph for the default one, and we get a nice little heart icon for my styled one instead, just to make it interesting. So if we were to look first at the XAML that makes up that page, we would see that we have 2 checkboxes defined in our XAML. So we have the default checkbox using the default style. You don't have to set anything on this one. And then we have our style checkbox that has a style set to my checkbox style. So if we drill down into my checkbox style, we'll see it here. You see we're defining our my checkbox style here. We're saying, okay, my target type is checkbox, and I'm setting this template to an instance of a control template. And so what's happening here is we're talking to the native platform and saying, okay, provide to me your native checkbox from within your system with all its functionalities and behaviors and richness, but also provide to me a blank canvas on top of that control so I can draw that control however I like. So I can do whatever I want to the visual structure of that control, but you're still going to be a native checkbox for the system. So you'll see here where we're making up, we have framework elements that make up the visual structure using grids, using rectangles, using font icons. And the only real change that I made basically was making a change to the radii of the surrounding grid and the rectangle that fills that circle for the background, that blue fill, as well as changes to the font icon. So you can see I have the radius here to make it circular, and if I zoom into the font icon, I have changed the glyph of this font icon to be from that check to a heart glyph. And those are the only changes really I made. So this is very small tweaks to a control template, but you can go crazy and do whatever you want within this template and make your control look however you'd like. Next, I want us to look at some of the collections of styles and brushes and resources that we have compiled together into what we call themes. So themes are an easy way to apply a whole design system to your application in just a few clicks and again, a couple lines of XAML. So the first theme that I wanted to look at is the Fluent theme. This is the default WinUI theme that comes baked into the Uno platform. So whenever you do a file new Uno project from within Visual Studio, you will start off with this theme being the default for your controls. All that's needed for you to start building using the Fluent theme is a simple line in your app XAML that's initializing the XAML controls resources from the Mux namespace that's shown here. So we're just initializing the XAML control resources, and the Fluent theme is bootstrapped and ready to go. And that's actually done for you by default in the Visual Studio app templates already. So you don't even have to worry about that once you do a file new Uno project. And these are also so it's the default theme, it's just this one-line setup, and these are also, they have the capability of having those V2.5 styles, I believe, and the 2.6 Sun Valley styles for Fluent that have the nice, rounded corner radiuses and stuff like that. So if we wanted to take a look at some Fluent stuff, we can go to the Uno gallery. And so this is the Uno gallery. So if you've never seen the Uno gallery before or know what it is, it's an application written on the Uno platform. So it's written all in XAML, and it targets all our supported platforms. And right now what we're looking at is that Uno application running natively in the browser using WebAssembly. So you can see here that we have multiple themes that we'll get into in a second, but right now I'm selected on the Fluent one. And it highlights, some of the Fluent controls, the styles for the controls that are available to you in Uno platform. So text boxes, checkboxes that we just saw before, buttons. If we wanted to look quickly at the Fluent palette, so the Fluent palette is basically just describing to you all the resource brushes that you have available to you from within the Fluent theme. So all your accent colors, all your base colors, all your Chrome colors, error text colors, anything you can think of that comes from the Fluent theme is here. And it's all adaptable to light and dark mode. It changes its variance to whatever you set the theme as. So if we look like a simple control, something like button, like we just saw before, you'd see, it's the default Fluent button that we all know and love, and it looks familiar to all of us, and it's using those 2.6 Sun Valley styles right now. And if we wanted to look at something a little bit more complex, we can go to something like the calendar view. And so this is the WinUI calendar view, the one that you're familiar with, using in WinUI applications, but it's running now natively on the browser, and it has that Fluent theme applied to it, and it's it works just as you would expect, and it looks familiar. It's following that Fluent theme to the T, using control templates, and everything's here for you to use. The next theme that I wanted to highlight is the Uno Material theme. So Uno Material provides a large set of controls, brushes, colors, resources, and components, all following materials design guidelines. It supports light and dark colors out of the box. There's even the ability to override and customize those colors as you wish, and we'll dig down into that in a second. It also has support for things like the famous ripple effect or drop shadows. And this, just like all of our themes, works across all platforms, all form factors, everywhere. So for Uno Material, we package this outside of the Uno UI package itself. So this is available as a NuGet package that you can add to your project. Simply install the package and initialize the material components in your app XAML, similar to Fluent. You see here, above here, we have that Fluent initialization with XAML controls resources. And here we are initializing the material colors and the material resources. And that's all you have to do, and the material theme is now bootstrapped in your app and ready to go. So if we go back to the gallery, we can go to the material palette. And so this is the palette now for material instead of Fluent. So you have your primary colors, your secondary colors, your variants for light and dark, and you'll see that they adapt between the different themes of your application, as well as all the background, the surface colors, the on primaries, the on secondaries, the on background brushes. So all these material design guideline notions for your colors are all here available to you as brush resources. So if we go again to a simple control, and this time we'll switch over to material, you'll see that it looks quite different. So we have our contain buttons, we have our outline buttons, and I believe we have text buttons down here, and they're all able to be clicked, and they're all interactable. They have that nice ripple effect on them as you go. And we also support more complex material controls, and some controls that are specific to material and may not have an exact WinUI equivalent. So we have the material card, say, which is built up of different framework elements from WinUI, but we built a card using these controls and using that nice ripple. So we have an elevated card, we have those outline cards, they're actionable, they contain each individual ripple effects, so everything is there for you, ready to use. And the elevated ones do have a nice shadow around the edge. So that's just an example of a more complex material control that's available to you out of this package. And so the latest addition to our themes offering is Uno Cupertino. So the Cupertino theme allows you to style your application following Apple's human interface design guidelines and gives your app that familiar iOS, macOS type of look and feel. And so it's the same exact setup as you would for Uno Material. You simply install the package and add those 2 lines to your app XAML and you're up and running. And so you see it looks very similar, except now we are initializing Cupertino colors and Cupertino resources instead of material colors and material resources. And you get these nice controls here. We'll take a look at the gallery again. This time we'll look at the Cupertino side of it. And so again, you have this palette that's I'm really driving home these palettes because we're going to get into customizing colors in a little bit. But you have these palettes here. So the main system colors, the variations for your gray schemes, control colors, and once again, adaptable to light and dark mode. All available to you as brushes resources from within the package. And so if we go to, I don't know, I guess button, and then we go to Cupertino, you'll see you'll have that familiar Cupertino iOS, macOS type of default text button, as well as a contain button as well. If we go to something a little bit more complex, like the calendar view, you see it's that same calendar view that we know coming from WinUI, so it's running in the browser natively, but now it has sort of a iOS, macOS type of look and feel to it. So it has that nice Cupertino blue on it. It has the nice icons that are matching more of the human interface design guideline icons. And it works just as you would expect. And you know, everything is there. It just has more of a Cupertino feel to it. And if we wanted to look at something a little more fun, I guess not, I don't know if it's fun, but it's fun for me. The progress ring I think is really cool. So if we go back to Fluent for a second, you'll see this is the progress ring that we all know, and it's drastically different for Cupertino. So it has that UI activity indicator type of look to it, and it's very familiar if you're familiar with iOS or macOS type of look and feel. And so that's the power of control templating. We can make this control look however we like, and so we made it have this Cupertino theme, and I think it looks pretty good. Finally, I want to bring us a little deeper into the themes and styling in general to see how you can really make your application match your brand, or perhaps have your own theme that you'd like to build upon. So the first step into customization, if you're wanting to build off one of our themes, is the color palette override. So when you initialize the colors and resources for either Material or Cupertino in your app XAML, you have the option to define an override source for your color palette. So let's take a look back to where we saw those color palettes in the gallery. Actually, yeah, I'll show you in a second. So those colors are all drawn by brushes defined in the Uno Material and Uno Cupertino packages. These brushes get their specific colors from what we call the color palette. So this is simply a resource dictionary of base colors that will be the stepping stone to defining your application's unique coloring and unique brand. So once again, if we go back to those palettes, let's choose the material one. These are being painted on this screen now by the material brushes coming from the material library, but they're actually based off of that color palette. So the brushes will reach out to the color palette and say, hey, give me the color for the primary color for this application, and I will draw that color out. And so the same idea for the variants and the light and dark, the secondary colors, all that stuff. And so if you ever wanted to customize those things, we could take a look at a small Android sample. So right now, we have a little Android application running now that has the slider in all 3 themes and buttons in all 3 themes. And you'll see here that this right here is the material slider, and this right here is the material button. And so it doesn't have that purple primary color like we were just looking at in the palette. Yes, in the palette in gallery. Because what happened here is I overrode those color palette values to be sort of a greenish, and I overrode the background palette color to be sort of a yellowy type of look to it. So how you do that, if we look in the code, actually first we'll start in the app XAML. So you'll see here that we have material colors being initialized, and material resources. And then what's happening for material colors is that I'm saying, hey, okay, go to this resource dictionary and override the color palette with whatever values I put in that resource dictionary. And so if I were to scroll over a little bit, that source is coming from my application, and it's called the material override XAML. So if we go into material override XAML, you will see a theme dictionary here for both light and dark. And I picked some colors that I wanted to override. If I don't override some of them, they'll take the default ones that are within material. But you see here that that primary color, oops, let me unzoom, that primary color here that we saw as in the outline button is that green that I defined here. And that background color, it's a little bit harder to see, but it is that yellowish type of look that you saw in the background of that button. So you have the option to override all of these, none of them, some of them, and it's all available for you, and the brushes will adapt accordingly, and you can easily use this to follow your branding for your application, for whatever it is. Of course, you always have the option to build your own theme and your own design. So nothing is stopping you from creating your own theme dictionaries to define your light and your dark resources. You can go ahead and define new styles and retemplate any controls that you like and package that up into a theme. Thanks to the powerful styling engine of WinUI and the wide breadth of platforms that Uno provides, you truly have a blank canvas spanning multiple operating systems and device form factors. And so we would love to see what kind of styles and themes that you can come up with, whether it's just a funky button that you created, or you want to take a stab at creating the next Material U theme for Uno. Whatever it is, we would love to see it and we would love to share it. So I'm going to drive home once again, whether you want to restyle a whole application or just a single control, Uno and WinUI's styling engine gives you complete control down to the very last pixel, while still providing you with the native functionality on any platform. And so with that, I would like to thank you for your time, and get out there, get creating, and definitely share with us anything that you make. We would love to see it. All right, so thank you very much.
Hello everyone. We hope you are enjoying your time at UnoConf 2021. Here at Syncfusion, we are grateful for the opportunity to be a part of this conference for the third year in a row. For those of you who might not be familiar with Syncfusion, Syncfusion is the enterprise technology partner of choice for software development, delivering a broad range of web, mobile, and desktop controls, coupled with a service-oriented approach throughout the entire application lifecycle. We also empower businesses to get the most out of their data with our enterprise solutions, Bold BI and Bold Reports, with the recent addition of Bold Sign, a comprehensive e-signature platform and development kit. Syncfusion has long been dedicated to cross-platform development solutions, most notably contributing over 155 components for cross-platform Xamarin development over the past 7 years. And now, launching a preview collection of controls for .NET MAUI, the next chapter of Xamarin. At UnoConf 2020, Syncfusion debuted our first control for the Uno platform, an impressive charting control that supported more than 10 chart types and numerous customizations. Along with this control, Syncfusion and Uno Platform recently worked together to publish Uno Platform Succinctly by Ed Freitas, a free ebook that serves as an essential guide to get developers started with their first Uno Platform project. More than 1 million users from around the world trust Syncfusion in their development process. So, if you're interested in seeing the Syncfusion difference, visit us at www.syncfusion.com to start your fully functional free trial now.
Hello everybody, I hope you're all enjoying the conference. Coming up next, we'll be speaking about a subject that I'm really passionate about, and it's about automated testing for Uno platform applications. I will be sharing with all of you during the next 20 minutes or so quite a few things that I have learned during my time developing Uno platform applications, and how can we develop the best test possible in a way that makes us save both time and money, and also how can we prepare our apps to be better tested. So I want to start this little section by speaking a little bit about myself. My name is Lester Botello. I'm a mobile software developer from Santo Domingo, Dominican Republic. I've been developing software for the best part of the last 20 years or so across a lot of different stacks inside the .NET ecosystem, but also outside the .NET ecosystem. I've developed web applications from all the way back to web forms, then MVC, a little bit of Blazor, Windows applications. But right now I'm focusing on mobile applications, specifically using Uno platform. You can find me all over the internet through my handle at Lester Botello, almost everywhere. If you have any questions about this talk or about any other subject, please feel free to reach out. So let's jump right into it. And I would like to start with a very brief introduction to automated testing. And to the uninitiated developer in testing applications, the first question that may come to our mind is, why should I even bother to automate my Uno platform application tests? I think we could argue that the main reason is, of course, quality. A tested application is less likely to have bugs, and that, of course, translates into happy users. While some developers might actually neglect writing tests for their applications, the truth is that tested applications not only ensure quality software is delivered to the customers, but it also reduces the time spent fixing obscure bugs, and as we're all told, time is money. So automated tests also help you ensure that your business logic produces the best results you're expecting. And this is especially important to catch things that can break after new updates, which is what we call regressions. And more importantly, automated testing can enable you to catch difficult to reproduce issues, which is what QA folks used to call edge cases. Edge cases are difficult to reproduce, but they're still important to fix because they might as easily break the user experience for any user. So there are a lot of different kinds of automated testing, but for Uno applications, we want to focus on a particular kind of automated testing called UI testing. UI testing focuses on the visual aspects of your app, as the name suggests. The idea behind it is to simulate user interaction with specific elements of your app and then assert any changes to the rest of the UI. UI testing also helps you ensure that the app is snappy. One of the things that can more easily discourage users from using your app is a slow and unresponsive app. So UI testing can help you identify those bottlenecks. But perhaps the most important aspect of UI testing is the reason for why it's most important, particularly for Uno platform apps, is to ensure the consistency of the user experience across all platforms and device types. So UI testing is made possible through something called Uno.UI tests, which is the cornerstone of testing Uno platform applications. Uno.UI test is built specifically for Uno platform apps, and it's based on NUnit version 3, which allows us to take advantage of all the features of NUnit, including the integrated assertion framework, which is amazing. Uno.UI test leverages Xamarin.UI tests for Android and iOS, and Selenium for WebAssembly. That allows us to test our applications not only on mobile, but also on the web just as easily. Finally, but not less important, Uno.UI test supports testing your application on a CI platform like App Center. That is very useful to actually automate the whole process. So that's about the introductory part. Let's discuss about what is the best way to ensure our Uno application is testable from the start. So we can summarize the steps for writing the best Uno platform application using these 4 steps. We're gonna try to go through each one of them. So one of the first things that we want to make sure is that our UI elements are properly identified. This will help our test scripts to easily find our controls in the visual tree once the application is rendered. Identification for Uno app controls is done through the xName property, which actually sets the automation properties.automationID property, which is what Uno.UI test uses to identify our controls. So the second thing that we want to make sure of is that we can leverage a base class that our tests can extend from. This base class is already provided by the default Uno platform test application template, but we want to further extend this class with methods that can handle common testing scenarios. The next step is we want to design our tests. We want to make sure that our test classes are grouped into each individual unit of work. For each unit of work, we want to have individual test cases, and for each one of these test cases, we want to be able to evaluate each expected outcome. So how does this translate into our UI? So in terms of how this translates into our UI, each unit of work should represent a page in our UI. Inside our page, we want to identify every possible interactive action that we can take on the page and write tests accordingly, writing one test for every specific outcome. So we identify our unit of work, we identify a test case, and then write tests for every outcome that we're expecting. Okay, this is really important to take into consideration, because when we are looking at our completed test, we are going to look for specific completed scenarios to be tested on. So that's about the theory. Let's move on to a little demo that we have prepared for this talk. So in this demo, we're going to focus on a simple application that we have created. It's a very simple Uno platform application. And we already have created a Uno.UI test project that we're going to use to test a single page in this application. So this is a very simple application. I already have it running here on Android. We're going to focus on Android for this demo for time purposes. For time reasons. But for this application right here, we want to focus on this login page right here. As you can see, we have a text box right here, and we're being asked to enter our username. If we come here and we enter our username, right, and say Lester, for example, and click on validate username, notice that we now have an error that has shown up at the top that says, please enter a valid email address. So we need to, the application is actually expecting us to use to enter an email address. So this name is not valid. So we're gonna go ahead and enter a valid email address using my personal email. We're going to click on validate username again. And now you can see that not only the message has disappeared at the top, but also a new panel has enabled below that has a new text box that allows me to enter my password, right? So we're gonna focus on testing this complete scenario right here, writing a very simple test class. And we're gonna move to our project right now. And the first thing we wanna do is we wanna take a look at the actual page that we're creating. So we notice here, we're not going to go through all the controls right here, but you can notice that some of the most important controls here have already set the xname property. Okay, this is important because when we are writing tests, and I want to write tests, for example, evaluating this error message right here, I will be able to easily identify this control using this xname right here, this string right here that says error message. So it's not necessary that we enter the xname property for all the controls, only the ones that we're interested in testing. But it's still a good practice to enter the xname property for all controls, because you might not be thinking about testing it now, but you might think about testing it later. So that's pretty much our page, right? And we already identified all the controls, so that part is okay. So the next thing I want to show you is the test base class. So this test base class that we see here is the same default test base class that is included as part of the default UI test project for Uno platform. This base test class already takes care of a lot of the boilerplate, like setting the constant and the initializers. It includes this nice property right here that allows me to take to hold off a reference of the whole app. But I can extend this class even further by writing some methods that I can use to be leveraged on any test that actually inherit from this test-based class. Here's an example. I have written a small method right here that is called tap element when ready, that basically takes as a parameter an element ID. With this element ID, then I'm able to call another method that is called query. This returns a reference of the method, and then I can wait for the element, wait until the element is ready. I have a second optional parameter that is called flash element. If I want to flash this element on the screen before I tap on it, I can pass this parameter right here, and then I flash the element, and then finally I tap the element. If I don't use this method, I have to write all this before I actually write my test. But now I have a single method that allows me to to perform all these actions using a single call. Okay, so let's move on to our main test class. So we have we are writing tests for this page right here that is called main page. So it makes sense that we name the corresponding test as main page tests. This allows us to easily identify that we are trying that when we are looking at this either in the CI or in the text explorer below right here, we will be able to see that whenever we see tests grouped under this, we are looking at the test for the main page. Okay, and this becomes our main unit of work. So the main unit of work for our test is going to be the main page. And then we're going to start looking at some tests that I have already written. So the first thing that I want to test is I want to test what happens when the email is invalid with the error message. So notice that I've written this method right here. The method name for this is it may look a little funny, but this is actually a good practice. It is a good practice to name your method in a way that the method itself can easily identify what the test is going to do. So right now we are testing when the email is invalid, the error message should be displayed. So when this test is running and is being displayed on whether it's in the CI or on the Test Explorer on Visual Studio, we will be able to see exactly what this test is trying to achieve just by looking at the method name. You can also see that I also set the description property of the test right here when I marked the method as a test, and this is a more friendly name, and the reason for this is because some CI tools might show you this method name, but some other CI tools will actually prefer showing this description right here. The same is true for different development environments. For Visual Studio, the Test Explorer will always focus on showing the method name. It doesn't show the description, but if you run this same test, for example, in Writer, you're going to notice that Writer is going to prefer the description right here. So this is why it's important to include them both. So let's move on to what the tests are actually testing, right? So for this test, I have already written the code for this test for time reasons. I'm going to comment this, and I'm going to uncomment this part of the test right here. So let's take a moment to read through all the steps that we're taking to actually test this. So the first thing that we're doing is that we're actually getting a reference to all of the different UI elements that we will be evaluating in this test. So I'm getting a reference to the error label using the query method that I already written here that actually looks for the marked property of the iApp interface. So I'm getting a reference from the error message, from the error label, from the username field, for the validate button, and for the error message, because I will be using all of them in my test. So I'm waiting for the username field element to be ready. I'm tapping on it. I'm clearing whatever text is already in that field already. I'm going to enter a text. Remember that we are testing what happens when the email is invalid. So we want to enter a text that does not actually conform to the email standard. And then we're going to flash the validate button, and we're going to tap on the button. Then we're going to write this little thing right here, that using the get dependency property of the uno.ui test actually allows me to get the value of a specific property. I want to take the value of that text property, and I want to assert if the value of the error message property equals, please enter a valid email address. So if I run this, see if I come here and run this test, let's go here to see it performing live. So if I run this test, it should do exactly what we are asking it to do. It's going to come up, takes a moment, it taps on the field, it writes the query text, flashes the button, clicks on it, and the message pops up, and if you can see right here, this little green check mark here, it means that the test passed. So the test results were correct, and our test is fine. But the only problem is that we needed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, a bunch of lines just to write this test. So since I have already written some methods to do all these things, I can just comment this out and comment this, and I'm going to leverage some methods that I have already written in the base class that already does all of this, and I'm doing each action just only once. Enter text when ready. I pass the query string that we're trying to set, and the name of the user of the field that we're trying to test. Tap element when ready, and we're passing the true parameter. That means that we want to flash this element, and then we're going to assert this using the error message field. We want to assert the text property, and we want to make sure that it's the same as this text right here. So I'm going to right click on it, click on run test, go back to our interface right here. And this test should do exactly the same. So it's going to come up it's going to enter the query string, flash the button, click on it, the error message pops up, and we have the green check right here. So we managed to write the same test using 3 lines, okay? This will be particularly useful when we are actually writing more tests. All of the other test scenarios are already covered. When email is valid, error message should not be displayed, and they are done in the same way. So that's about it for the demo, and this is what I have to show you folks today. I'm gonna leave you with a few references. There's a great book, Creating Cross-Platform Applications with Uno Platform by Mike Lacey and Marcel A. Wagner. There's a nice blog post, and the code for this demo is already in my GitHub repository. So you guys can go fetch it out and play around with it as you see fit. So that's it for the demo. Thank you so much for being with us today, and keep enjoying the conference.
Hi, my name is Andres Pineda, and I'm very excited to be here. Welcome to my session. Today, we're going to be talking about how could we deploy Uno Platform web applications into Azure. When I say Uno Platform web app, what do it really mean? And why is Uno Platform web applications different from any other web applications? Well, when we use Uno to compile web applications, we are in fact compiling it to WebAssembly. In case you haven't heard of, WebAssembly is this new technology that allows, in theory, taking any language and compiling into this intermediate pseudocode that will run natively on the browser. This removes the necessity of a web server, and it makes it the perfect fit for Azure Static Web Apps. Azure Static Web Apps is a service that allows hosting static content on Azure by connecting a core repository like GitHub or Azure DevOps, and it will automatically build and deploy your applications based on code change. The main benefits of Static Web Apps are that it provides the easy way to use a custom domain, built-in TSL certificates, and free built-in authentication and routing. Let's jump into the code so you have an idea of what we're going to be shipping. Here we have Uno application that we created by using the command line or the terminal, the command line template. Basically, we just .NET new Uno application and provided the required information. For this sample, we're going to be using Visual Studio 2022, but you could also use Visual Studio Code if you want. Let's build and run the application so you have an idea of what we're going to be using. So this is, as I mentioned, a very simple application, and right now we are running the Windows project. If we do some small changes, it automatically reflects those changes. But let's jump into Azure, where is that most of the work is going to be done. If you don't have an Azure account yet, I invite you to create one. You're going to be getting a 200 credit that you will be able to use in your first 30 days. As well, that subscription is going to allow you to use some services for a whole year and other services for like forever. We are right now in the Azure portal, and from here, if you want to create a static web apps, we can just use the search from the home and just pick it from here. Here we're gonna create a new static web app. And we're gonna be filling some of the information that is required. I'm gonna be guiding you through. So here is very straightforward. The Azure team did a very good job making this as simple as possible. So in order to create a new resource, we don't have to go into too many details. From here, we have to create a new resource group. A resource group is basically a way for us to group other resources that are going to have the same life cycle, the same permissions, and the same policies. Let's just create a new one, and we're going to call it WinUI on the web. I call it RG for resource group. Here, we're going to be using the name of the static web apps. This can be anything. This is not what is going to be shown to the end user, but I suggest you to keep this name close to the name of the project that you're going to be hosting here, so you don't get confused. So for the plan type, and for this example, we're going to be using the free for hobby personal projects. And for the Azure function and staging details, we're going to be using Eastern US. For this example, we will not use Azure functions, but we will be showing some part of the presentation how to the staging part. So here is something very important. Is the source. Here you can select either GitHub or other. Other means that you can use Azure DevOps or any other source code repository that you're using. In this example, I'm gonna be connecting my GitHub account. It will ask for the credentials. You authorize, you sign in, and you confirm your password, and it will connect your GitHub account to your Azure. Here, it asks you 3 more information, and it is the organization. For this, you're going to pick the organization where your code repository is located. The repository that you want to be working with is WinUI on the web. And for the branch, make sure you pick the correct branch. This is very important, as this is the branch that is going to be triggering the build and the deployment. You might want to use another brand other than the main if you wanna, or if you wanna keep the latest changes that are in the main, you use that one. Build details. This is, you're gonna select the type of application that you are gonna be building. Uno platform is not currently on the list. So for this example, we're gonna be using custom. All this, you leave it like this, and we will come back. Later, I'm gonna show you what I'm gonna be using for this. But for now, just keep it as it is. Preview and create. At this time, there are 2 things happening. When we click on create, Azure is doing the initial deployment of our application. But at the same time, Azure did an initial configuration for the CI/CD. If we go to the resource that was already created, we are going to be able to see the application that was just deployed, but as well, we're going to be able to see the CI/CD pipeline that was triggered by Azure. Initially, if we go to, as you can see, this is the repository that we're using. And if we come to the code, we're going to see this new directory and this new file that Azure created for us. This file contains the initial configuration for the CI/CD, which is actually a GitHub Actions. We are using GitHub as our repository and GitHub Actions for our CI/CD. We will have to make some modifications to this file because as mentioned before, Azure still doesn't have the configuration for our Uno application. The configuration is very straightforward, and we're gonna do it straight from the browser. Because of this nice feature that GitHub included, you just go back to the homepage and tap on the dot, on the period. This will open Visual Studio Code editor that we can use to do the modifications that we need to make it work. At this moment, Visual Studio, the online version of Visual Studio Code, is loading our project and making sure we have everything we need in order to for the project to work. But since we will only gonna be modifying this file. Remember, the file is inside that GitHub directory, and it will use name that is basically the name that Azure for the website that Azure used, the URL that Azure used when deployed. As you can see, this is the actual website. It doesn't have anything. It is empty because we haven't done the initial deployment. I want to show you something else before modifying the file. This failed, and as I said, we knew it was gonna fail because of this configuration that we need to do here first. So I'm gonna copy and paste everything, and then I'm gonna be guiding you through the different fields that we added. This is a YAML file, and basically here we are adding a new step. So it already had one step, and the step that we are adding is so we need of a way to tell Azure GitHub Actions how to build and where to find the executable. So we are setup.net. This is the step that we are adding. We are using this actions, which is for the GitHub Actions. We're using the .NET version 5.0. This will depend on the version that that your project is actually supporting. This project that we are using supports .NET 5, but .NET 6 just got released. If you want to migrate your project, if you want to start using .NET 6 for your project, you can definitely use it, but just make sure that you're using the correct version here. Here we're just telling the GitHub Actions to navigate to the project where the WASM head is, and also we are telling how to compile. Something else that we need to do is telling GitHub Actions where to find the final executable that's going to be deployed. So right now, the application source code path is pointing to the root, but we're gonna be modifying this with the correct information. And basically, it is the WASM project binary releases .NET 5.0, which is gonna depend on the .NET version that you're supporting, that your application is running. In our case, this is .NET 5 and the distribution directory. All we have to do now is save this directory, and by without leaving the website, thanks to the this nice feature that GitHub has, we can commit this change, update YAML for CI, and then we just commit. There's no need to push. We are working straight on the repository. Probably for a production application, I would not advise you to do this, but instead create a pull request that you can then later merge. But since this is a sample, this is okay. By committing, we just trigger a new release. While this is compiling, I want to show you a couple of things. On the website, do you remember one of the benefits that I mentioned? So basically, this is one of the benefits, and it is the fact that you get for free TSL certificates, and it will renew automatically. You don't have to configure, and you don't have to come here later and do anything else. While this is compiling, I don't want you to wait until this is finished, so I'm gonna show you the final version of how it looks, and then we come back here so we can see the final page. Did I mention that another benefit of the static web apps is the fact that our static content is globally distributed, making it very close to your final user, so that when they access your application, the application is gonna load really fast. That's that's a very good feature for static web apps. Still building, but in the meantime, this is the same project that I created static web apps previously, so we didn't have to wait for the CI/CD and the deployment to finish. Here we have the final results. This is the project, the same one that we have, but now running in Azure. If we come back and we say we would like to do some modifications, and then trigger create a pull request and trigger a new build and see the changes happening, this is also possible to do. And by that, let's say that we would like to change the image that we're using here, and instead we want to use this image that it's called, let's use this image. And so you have an idea of what are the modifications that I did. I'm just gonna run the project locally again. Yes, well, in this case, I don't want to use any width. I wanna keep it, so just this modification, and let's say that we wanna ship this modification and see it happening on the CI/CD. All we have to do is just is create a branch with the changes that we want to keep. Let's say that let's create a new branch and then update page, update main page. We're gonna commit these changes. Oh gosh. Update main page. And we're gonna push it. Then we can create a pull request with this, and I want to show you something nice that happens when you do that. Actually, it's this one, yeah. So when we push a new version and we create a pull request, the pull request will create a staging version of our application that Azure allows us to go and see. It deploys another version of our application that we can see. If we want to see it in action, we just go to the repository. See if the one that we triggered previously is finished. So we refresh and if we come to the repository and where is this repository? Yeah. And we navigate to the actions. We see that we created the pull request that we created. We can see the logs of the pull request. Actually, we navigated to we want to see the logs of the bill. And we navigate to the logs. And if we go to the build and deploy, come on, Azure. At the very bottom, we see that Azure stated deployment completed, visit your website. You see that the name is the same URL, but it added the commit hash that was used for this build. And there we have the Azure, the staging environment with the changes that we, for the pull request that we created. Before closing, I want to show you one last thing, and it is how we can configure custom domains. This is nice if you are playing around, but when you wanna use your brand, you will want to use a custom domain or domain that represents your brand. And for that, I got this domain that is. Let me open a new tab. So WinUI everywhere.com. Oh, it's loading. And there we have our application that we hosted on using Azure Static Web Apps, using TSL certificates, and also using a custom domain. I hope you like it. I hope you find useful this information. And I invite you to go to the documentation, both for Azure Static Web Apps and Uno platform, in case you have any doubts. Also, you can find me on the web. Thank you.
you.